in this class, we're going to study about object-oriented programming in Python world, how to do Python. So in Python, as we discussed, there are two approaches. Either you can use functional approach without creating object, without creating classes. Also, you can do fast prototyping. You can build the project, okay? And especially in the data science project, like ML project, deep learning project, people usually use functional approach. They don't create classes, those all things. All the data scientist people, they're very lazy. They don't focus on good writing code or modular code. They just focus on writing some POC, some script, and they want to get the result, okay? But in the world of generative AI, where you are building AI system, you are building application where we have to focus on building good modular kind of program, building application in using object-oriented concepts. So you are more like a developer here, okay, not like a data scientist, okay. So that is why object-oriented programming becomes very essential in, especially for generative AI kind of projects, where you have to build RAG system, agentic system, those things. Because I have seen in the project, they focus on object-oriented programming, okay. So if you're coming from Java world, I'm assuming that all of you have a Java background. So I'm not going to touch very basic, what is class, what is reference, what is a static, what is instance, what is inheritance, what is polymorphism. Okay, I'm assuming that you already have these basic concepts. You're not new to object-oriented programming. You know this all concept pretty well. That's my assumption. I'm assuming that, okay. So here, whatever concept you have, like what is encapsulation, what is polymorphism, what is inheritance, what is static class, static methods, okay, what is how to do abstraction, how to create classes, how to create objects. So those things we are going to learn in the Python space, and maybe the syntax can be different here. Yeah, syntax are pretty much different here. But the concept, more or less, the concepts about object-oriented is exactly almost same. There are some couple of variation, I have seen that, but more or less the concepts are pretty much same as for object-oriented, okay? So here I'm not going to start from scratch. So let us understand that how we implement object-oriented in case of Python world. Let us see that, okay? So basic thing is about creating class, okay? I hope you know what is class. I'm not going to teach you what is class. So in the Python world, how to create class. So for that, we have a keyword called class, okay? And here, for creating a class, we follow kind of what is called camel case kind of structure, okay? Always start with a camel case, the class name, okay? If you're creating a function name, those things you can use lowercase, but creating a class, always good practice to use camel case. So how we create a class in Python?
Title case.
Sorry?
It's the title case, not camel case.
Yeah. Yeah, so how we create a class in Python? So we have a class keyword and give a class name. You follow all the rule of identifier, give a class name, okay? And colon, you know that in Python, we have to use colon. Whenever you have multiple block of code, use colon here, okay? And follow all the principle of identification, okay? And here in Python, let us understand, every class has some constructor, right? As we know that, okay? So in Python world, how we create constructor? So in order to create a constructor, we have to use init function. So this is the constructor in Python, okay? User def. So in constructor is a function in Python. In Java world, constructor is not there are some different, it is not a method, okay? We learned, right? In the Java, constructor is not a method. But in Python, it's a function constructor, and it has a special name, okay? If you're not giving init, then it will not consider as a constructor. So anything you want to keep as a constructor, it should be def underscore init underscore. Okay, so this is a predefined function. Okay, if you see in the previous classes, right, we have seen that if you, for example, anything, yeah, if anything, you create anything, right, like integer, float, anything, you will see they have an inbuilt init function. So they are constructor basically, because in Python, everything is object in like string, float, Boolean, everything is object. So they have an inbuilt constructor, okay? So if you want to create your custom class like this, you use init function def, okay? And always the first parameter to init should be self. That you have to remember, okay? If you're not giving self, then it will I think it will give error. Okay, so always remember that the first parameter should be self. So self is like a this keyword. Okay, so self refer to current object. I hope you know what is this keyword in Python, right? It's referring to the current object. So that is a self. So self is like a this in Python. Okay. So I'm giving, so for this employee class, I want to get a constructor with name and salary. I want to initialize this value, name and salary. So this way I can do it, def, init, and self. Okay, self is a inbuilt keyword, which is referring to this. And pass your user defined whatever you want to initialize. It can be anything, name, salary, age, department, whatever. Okay, so pass those parameters. Okay, and then you are assigning here. So this way we are assigning the these two variable. Okay, self is a keyword. It is pointing to current object. So self dot name is equal to name. I think this statement you are understanding, right? We are just assigning. We are assigning this variable into our instance variable. Okay, so self dot name, self dot salary. Okay, self dot department none, and self dot SSN. Okay, so this way we initialize, we create a class object, and we create a constructor. And constructor will have always self. First keywords will be self, and remaining will be your user defined parameter. And we can define the parameter inside my self. Okay, this is one thing. And the important thing, in Java, we have very control way to access. Like we have a private, we have a protected, we have a public. Okay, I hope you know that to control the accessibility of any object of any variable. Okay. In Python, we don't have that keywords. In Python, we don't have a public or a protected or private keyword. Okay. So in Python world, how we handle it? So actually by default in Python, everything is public. Okay. By default, everything is public. Okay. So for example, if I'm doing self.name, you can see that self, I'm creating self.name. Okay. So if you're using self.names, it means that you're creating an instance variable. Okay. So self.name and salary, these are both instance variable. Unique to each instance. I hope you know what is instance variable. Okay. So if you're using self.name salary, these two are instance variable, and by default, it's a public. Okay. Anybody can access it. Okay. If you want to make it protected, okay, then you have to use one underscore. Self dot. If you're using one single underscore, it is assumed that it's a protected. It's a convention only. Okay, it's not a hard rule. Okay, what is a protected? I hope you know that, right? Protected is something that only subclass can access it. Within the class, it is more like you can access within the class, but outside the class, only subclass can extend it, can inherit it, can get the access, right? This is a protected. So if you want to create a protected version of Python, then you have to use one single underscore. Okay. So if I'm using, you can see the difference. Okay, self.name, in the name there's no underscore. It's a simple. Okay, so if you're not using any underscore, then it's a public. It's a public instance variable. Okay, if you're using a double underscore, single underscore, then it's become a protected. Okay, by convention. Okay, but even external things can access it. There's no hard rule that only subclass can access it. Even anybody can access it. It's more like a public. But it's just a convention to tell that, okay, if I'm using one underscore, it is assumed like a protected. Just like a constant, right? In Python, we don't have any what is final keyword. Okay, in Python, we have a just convention that for a constant, we give a uppercase. Okay, here also it's a convention only. For the protected, use a single underscore. Okay, if you want to make a private something, okay, then we use double underscore. Okay, self dot double underscore. So if you make anything double underscore, then it become private. So nobody can access it. But there's no any such keyword like private. There's no keyword like private. We handle with this underscore only in Python. So this is a major difference. Okay, you will not find any keyword like protected or public or private. You have to handle with this underscore only. Single underscore, it is assumed like it's a protected. Double underscore, it is assumed like it's a private. Or without underscore, it is assumed like it's a public. So everything become public.
Even for double underscore, the same applies, right? By convention, everyone can access.
No, no, for private thing we cannot access. I will give a demo. Okay.
Okay.
I will show something. Okay. So this, I hope you're able to understand what is how to create instance variable, how to create private variable, how to create protected variable. Okay.
Yeah.
And anything here, anything, if you're creating anything at the class level, okay, it becomes a class variable. Okay. So we have instance variable. Okay. So in Python, in Java, how we create class variable? We use static keyword, right? So we don't have a static keyword in Python. So anything if you're creating at the class level, it automatically becomes a class variable. We don't use any static keyword here. Just create anything at a class level, it becomes class variable. So it is shared across all the instances. Okay, the concept is pretty much same. Okay, what is a static? What is a class variable? Concept is pretty much same. Only thing we are doing in the same different way. Okay. So if you're creating anything at the class level, for example, company and employee count. Suppose if you want to get an employee count as a static, as a class variable, use create at the class level. It is assumed as a class variable. Okay. So here company employee count it's a class variable. These two are class variable. Name and salary is an instance variable. Okay. Department is a protected variable, and SSN is my private variable. This is clear. So how we create class variable, how we create instance variable, how we create protected and private variables. Okay.
Yeah.
And how we create constructor in Python. Okay. And this method get details. It's a normal method. Okay. This is not a normal method. It's a init. It's a constructor. Okay. And this get details is a normal user-defined function. Okay. And always your function, when you're creating a function, user-defined function, always give self as a first parameter. Okay, it's a convention that always give us self this. Okay, even for your own user-defined function as well. Okay, so here my intention here is that I want to create employee with the name, salary, department, and SSN. Okay, I'm assigning it, creating constructor, and company is my class variable. Employee count is a class variable, and I want to give some details. So I'm giving a getter. You can assume it's a getter. Okay, I'm passing self, and I'm returning some value here. Self.name and self.salary. I'm giving some message here. So this is pretty much one simple employee object. How we create employee object with constructor, with class variable, with protected variable, with private, and giving a getter.
So Raj, sorry to interrupt you. Yeah. Get underscore detail method name or get?
No, there's no any get. So you're saying get, right?
Yeah.
No, there's no. No, you can give any name here. Okay, get any name here. Okay, so in Python, there's no any convention to setter getters.
Okay.
In Java, because Java is very protected, right? In Java by default, all the instance variables should be private, right? Here there's no concept. Okay, so here we don't have a setters and getter concept. So by default, everything is a public variable. Okay. If we want to make it private, then you have to use, we have a way around that. We have a workaround that we will understand. We also have a setters, getters here, but we don't have a strict rule that we have to give. We have to make our instance variable as a private, and we give a setters, getters, poju like. Okay, we don't have such here restriction. So it can be any function. It can be any function. This is up to you how you define a person. But it is not like a typical getters. Don't confuse. Okay, it is not a setters getters, typical getters of Java. It is just a function, any function. Okay, so I'm running it. So this way I'm creating a class with some variable, with some constructor, and with some function which will return some value. Okay, so this is a class. Once you want to get the object, okay, so in Java we have to instantiate the object in the class, right, using the new keyword. Okay, so in Python there's no new keyword. Okay, so how to create object of it? Just call the this class name, whatever class you have created. Okay, and whatever constructor you have declared. For example, here I have declared name and salary. Pass those values. That's all. So I'm calling if you're creating this syntax employee this, it means you're calling a constructor. You're calling init method basically. So this is nothing but you're calling init. You're creating an instance of employee with these two instance, whatever you have declared, like name and salary, you're passing it. Okay, so this will create an employee object. This line. Okay, so again I'm creating two employee objects, employee 1, employee 2, with different name, different salary. So I have two employee object. Okay, because I have two employee object, and this employee count is a what? It's a static, right? It's a class variable. It's a static. Okay. So so this will be shared across these two variables. Okay. So what I'm doing here, I'm incrementing. Okay. This class variable I'm incrementing. Okay. And how to access the class variable? You can access using the class name, just like in Java also, right? You can see that I'm accessing employee count using employee class name dot this variable. Okay. If you want to access the instance variable, then you have to use self. All instance variable you have to use self. Okay, like self, name, department. For a static one, for the class variable, you don't have to use self keyword. You can use directly class name dot your variable name. So here for whenever I'm creating object, I'm just incrementing the value of employee count. I just want to count the number of objects, how many objects I'm creating. Okay. So first I create first object, the count it was 0 initially, the count become 1. And for next object, the count become 2. Okay. So that's why I'm just counting it. Okay. So this employee count is a static. It's a class variable. It has nothing to do with instance. Okay. But company also is a static. Okay. So company has nothing to do with instance variable. Okay. And get details is a instance variable. Okay. This class variable. Okay. Either you can use reference. Okay. Like this, for example, here I'm using reference, or you can use class name because it has a class property. It does not matter. Okay. So I can use like this also because company is a class. It's a class variable. So I can use class name dot property. So both will give you same value. Let's run this xyz. Okay. Like this. So you can use reference also for accessing the class variable, but because it's a class method, so it does not matter. You can use either reference or use either the class name.
Well, I have a question.
Yes.
In the template, right, in the definition of need method, on the last line, you have used employee count plus equal to 1. Do we really need to prefix with the class name for accessing?
This one, right?
This one.
Yeah, it needed, yes, because you are accessing this this class variable within the class.
But we already within the class, right? The method that we declared init is inside the class. So do we need that prefix employee dot?
You're saying this prefix employee underscore count, right?
Yeah, this is a variable, class variable.
Yes.
But while we're incrementing, right, we are incrementing with the help of prefix dot employee count. So externally is okay. Externally we can access with the class name, but internally inside the method, do we need this fix?
No, but see, it will not
like this. Yeah.
Like this. Okay.
Yeah. I'm just checking.
Like this, it will not work because this employee count, it will not access. Okay.
Okay.
Because cannot access local variable employee count where it is not associated with a value. Okay. So it will not able to access it. Okay. Because see, this init is more like you're trying to because init is more like it's an instance. It is connecting with the instance. Okay. From the instance you want to connect, you want to call some class variable. So it will not find the value. So it's always good practice whenever you want to refer any class thing, use class name.
Okay. Because in I'm just collating Java, where we used to call a static variable inside the instance method, but here it's not possible.
Yeah. Yes.
Okay. Understand.
Always refer class name.
Class name. Okay. Right. Yeah.
Okay. So you got right. So I hope you got a lot of things here. Constructor, self, instance variable, protected variable, private variable, class methods. Okay, how to access it. Okay, and how to create objects. Okay, this is the free. So I think you got a lot of things from here. Okay, so this is the basic class structure: how to define a class, how to define a constructor, and how to call it, how to use the objects. Any doubt here till now?
No.
Okay. Fine. Yeah, private thing I'm covering later. Okay. So private thing I will cover later. I have the next chapter. Okay. So this is the thing, how we create objects. Okay. Next topic I want to cover about the class and instance variable. Okay. So if you anything, if you're using with self, if you're using, for example, here name and price. Okay. So if anything you are defining within the init block, okay, then it becomes like an instance variable. And if anything you are associating with the self, for example, I'm using self.name, self.price. Okay, so this name and price will consider as a instance variable. Okay, one thing you notice that you don't have to declare here. And for example, in case of Java, we have to declare, right, at the class level, that we have to declare the instances, right? This is my private, is something like that. You don't have to declare that. You need the inside the init function, you just call self, so it will automatically create instance variable on the runtime. You don't have to declare it. Okay, if anything you're declaring at the class level, it becomes automatically class variable. So how to create instance variable? Using init method and use self. Okay, and access with the self, it automatically becomes instance variable. If something at the class level, it becomes automatic class level, class method, class variable. Okay, so this is a way to create instance variable and class variable. Okay, and here I have some function taking self. Okay, and I'm accessing price and discount. Okay, so discount I can access here also with the self. Also I can also access from the product also. So I'm creating two product here. So this discount is a class variable. Okay, it is not an instance variable. So that's what I want to demonstrate here. So I'm creating two product, laptop and mouse. Okay, price and because name and price are instance variable. So this name and price is instance variable, right? And get discounted. So I'm printing some discounts here. Okay. So here, what I'm going to demonstrate here, I'm changing the class variable. Okay. For example, you can see that product dot discount. I'm accessing this class variable with the class name. Okay. So I'm saying that initially it was discount was 0.1, 10%. Now I'm making 20%. So I'm using product dot discount. Okay. So I'm changing the variable. Okay. So it is possible. Okay. So I'm changing the variable with the class name. Okay, because it's a class variable. Okay, so what you change the class variable, it will affect all the instances. Okay, so after the change, okay, if I calculate the discounted for first object, I want to calculate discount, so it will impact both the classes because it's a class variable. I hope you understand that concepts. Okay, so here yeah, there's some dict function. Every object will have a dict function. Okay, if you want to convert your classes, your object into dictionary format, for example, I have a name, I have a price, I have a whatever property it has, like name, price, discount, you want to convert into dictionary. Okay, from given object, I want to get all the data into a dictionary format, then you can use dict function. So it's an inbuilt function, p1 dot dict. It's not a function, it's a property, dict. Okay, actually it's a function internally. It converts, it takes all the attributes and convert into dictionary. So you will get dictionary like this. Okay, so it is more like a serialization. Suppose you have some object in memory and you want to serialize into maybe in dictionary. You want to get all the property, all the instance variable or class variable, you can use dict like this.
One question. In the third one, right? Change instance variable affects only that instance. Next one. Here you're making P1 the discount as 0.5. But this one is class variable, right? It's not instance variable.
Yeah, for instance, it's a class variable. Okay. So okay, okay, you're saying that it is affecting only that instance.
Because this time we are not using class name. We are using an instance.
We're using only instance name.
So it's adding a new variable to the instance. Even the dict also depends the same, not adding one new variable called discount in the P1 instance. So.
Okay, P1, yeah, change instance variable. Changing instance variable. P1 to discount. Discount is it's a class variable. It's not instance variable, right?
Okay,
P2, it is not. 1 second. Suppose if I remove this code, okay, so I have two product and initially the discount is 10%. So it is giving me a discount, okay, and then I'm changing the discount with the first reference 0.5. So P1 discount, it will affect P1. Let us run this. So laptop 10, the discount is 10%. So P1, the discount is this.
P2 is not getting affected, right? Because P2.
Okay, so now discount initially is 10%, and now I'm making P1. Let us see. Okay. So it is affecting, right?
That's affecting only for P1.
It is only affecting for P1, right? And for P2, it is
still 40.
It is 40. And I can see for P1, it is creating a discount here. And for P2, there's no discount. And product dict content discount, because I'm calling a class, so it will give me discount. Okay. So I think it is more like a creating instance variable. P1 discount.
It's creating instance and
1 second. If I change it product, 1 second. I think because of self, it is maybe creating it. If I access with the class name.
Okay.
Okay, still coming a discount. Okay. Okay, 1 second. Let us see what the discount coming here. So discount is 0.1, so it should give me 0.1. Okay, for this P1, okay, let us see. So instead of 0.1, I'm printing 0.1. So though I'm making 0.5, but P1 dot get discount, it is in 0.1. But this, okay, it is creating both giving only disconcerting, okay, because okay, I have, if I do a self here, okay. So with the self, because if I do a self, then it is creating a new instance variable, I think.
Yeah.
So if I say discount, P1 discount +1, and okay, P1 dot discount. Okay, I'm setting, okay, it is setting the discount variable. Instance variable, I'm setting a new thing. So discount will become like an instance variable, not a static here. So for the P1, it will become like a 0.5, and for P2, I'm not setting, still it will consider the class variable 0.1.
So once we try to override, it is taking that value, right? That is what
Yes, it's trying to overwrite. Yes. So discount is static here. If I do product, then it will not do, because self, it will create instance variable.
Even that also.
It is doing it. Okay, it is creating also. Okay, it is creating, I think, because it is changing the value actually. It is changing, I'm changing something here, changing the value. Okay. If I don't do this, if I don't set it, then it will, I think, will be same.
Yeah.
0.1, 0.1. It is not creating any object here, any variable here, because I think it is setting the variable. I think it is, see, actually, run this. See, what it's doing, it is doing kind of, it is getting, I mean, at the class level, it is still discount, okay, at the class level. Maybe it is creating another instance variable. Maybe the name is same, okay. It is doing kind of shadow, but it is creating, you can see that for P1, it is creating a discount as a instance, it's instance variable, okay. But for the class level, if I see that for the class level, the discount is still same. For the class, it will remain same, but for object level, you are changing, actually you are creating, you're creating instance variable basically here. But at the class level, this will remain same. You can see that even for the P1, P2.
So once we access with the instance variable, it is adding a new variable to the class. Okay.
Yeah. So if you want to get the class, then you use a product, I mean the class name. Okay. So it is always safe. Okay. So class name will always refer to the class variable, not the object level variable, instance variable. Because here, I think it is setting the new value. Okay. It is creating a new instance variable. Okay. Because see, we don't have a protection. We don't have a like private here, like, so it is trying to set, we have a name and price. Then here I'm setting a new product, new discount. It becomes an instance variable basically. So now for P1, it has name, price, and discount. These three are instance variable, but it's still discount is the class level, at the global level. So this discount can be, that's why it is printing discount here. It's become at the instance level. But for the class, discount is still there. It is still a class variable. So it is always good practice, if you want to make something class level, use a class name to refer it.
Okay.
So it will be used as a class level. Okay.
Can you uncomment and run now? With the same logic.
Yeah, right. Self.
No. You uncomment the current line, and the previous line you keep as such. Yeah.
This one, right?
Yeah. Yeah. Can you run now? I think now it's clear. Right?
The product, it will consider, I think, only 10%.
Okay.
For discounting, it will consider only 10%. So I have P1 is at 1,000. I'm making a discount. I'm discounting it. So it should consider only 10%. Let us see. 10%, right?
Yes,
10%. But it is getting a new variable, but for calculation, it is referring the class variable, because I'm using product. If I make it self, then it will consider the instance variable.
Yes. Yeah.
Now let us run this.
Now
it will consider for 50%. 500, yes. So if you want to refer the class level, it is always practice to make a class name dot variable. So it will consider as a class variable.
I understand the logic now. So once we add a reference any variable newly, right? It is adding a new variable.
Yeah, it will add, because you are setting it. You are setting it. Okay, you're creating a new instance variable. So it is possible. Okay. But it will, this class variable remain there. It will still remain at the class level, global level, but maybe at the instance level, you're creating a new variable, like kind of shadow. You're creating a shadow of it. But while calculation, you have to consider the static variable, use a class name while doing any calculation. Okay. So this is how we create, this was a good catch, by the way. So this is how we create instance variable in class variable in Python. So class variable always use at the class level, okay, and always refer with the class name. If you want to keep, if you want to make as a class level, your calculation depending upon the class level, use always as a class name to refer it. It's always a good practice. Okay. So we saw that class level and instance level. Okay, how we create that. Okay. And name. Okay, now think about the private. Okay, so here I'm creating a bank account and I have a init, I have an account number, I have a balance. Okay, so account number is a public, it's an instance variable, and by default it's a public, so anybody can access it. Okay, and balance is a protected. Okay, because I'm doing a single underscore, and pin I'm doing 1 2 3. It's a private. Okay, and I have a get balance, so I'm returning balance here, and I'm creating a private method. So see, validate pin, I'm doing underscore. Okay, so I'm creating a private method like this. So by this you can create private instance variable. By this you create private methods. Even you can create, if you single score, it has become like a protected method. Okay, so this is a convention. I have seen, you will see that in the code using before the function use under single underscore, it become protected. Using double underscore become private. Okay, so this is my code. Okay, and here I'm creating a bank account with the account number and balance. So account number is a public instance variable. Account and balance is more like a protected. Okay, protected. And here here I'm trying to access account number. This is which is a public, so I can access. Okay, and here I'm trying to access balance. Okay, so balance is a protected. Okay, but still I can access it. It works, but not, it's a convention but not enforced. Okay, so even for the protected thing you can access outside. That's what I want to demonstrate here. So account number, it was a public, so I was able to access, and balance was a protected, so I was able to access. So both I was able to access. Okay, but let's suppose for the pin, I want to access the pin one. Okay, so pin is a private one. Okay, I want to access it from this reference, account reference. Okay, account.pin. Okay, I want to access it, so it will give you error. Okay, so it is saying that this object has no attribute called pin, so you cannot access it. It is giving you attribute error. Okay, but still, if you want to, you cannot access it like this. Just calling the reference name and the private variable, you can't access it. Okay, but there's a way to access it. I found that like this account, it is called name mangling. Okay, it is called Python transformer pin to bank account pin. So how to do that? Account, your reference name underscore bank account. Okay, bank account is your class name underscore pin. Like this you can access. It is not, and it's kind of cheating. You can access it, but we don't encourage to use this kind of code. Okay, but it is, you can access it 1 2 3 4 like this. Okay, but generally we don't access like this. Whenever you create like anything private, if you're trying to access normally using the reference, it will give you attribute error. You cannot access it. Okay, so this way. But for the protected, you can access it. It is only convention. It is not going to stop you. Okay, so this way we create public, protected, and private. Okay, and let's suppose I'm calling validate pin. Now let me call it, because it's a private. Whether they will call it not, let me call it count dot validate pin. Let me call it. I think it should throw error. Pin. Suppose I'm passing what is the pin? 1 2 3 4. It will give you error. Attribute, no attribute. Okay, so anything with the starting two double score, you cannot access outside. It is within, you can call within the within the function, within the class.
Really, it's very strange because
Yeah,
we used to leave on compiler for type checking and access checking,
yes.
but now we have to behave properly as a good adult.
Yes.
Okay.
So it's yeah, first time you'll find very awkward. Even I find it was very awkward here. First time I was learning this thing. it's not very strict. It's just a convention. Okay, so you have to be. I think as a developer, you have to be mature to follow these practices. Okay. So how we create public, how we create protected, how we create private. This is the way we create private. And private, using double underscore, you cannot access it. Okay, so private is safe, but protected is just a convention. Okay, and here by default everything is a public. That's a strange in Python. There's no any protection. I think in Java world we make sure that all my instance would be private. But here there's no any such rule. It's all, everything is public here by default. Yeah. So these are things. So yeah, this is a philosophy here. We all consenting adults here. Access control is by convention, not enforced. This is the philosophy that Python follow. So they are assuming that you are mature. Okay.
But in a group of team, if you're working in a team, a large team, right, it's very difficult to follow.
Yeah.
Okay.
But yeah, that's I mean, for example, I was real about creating a constant. I mean, there's no any static or any final keyword in there. So there is just a, suppose you want to get some constant, you just have a convention that create a uppercase, and the people will assume that it's a constant, but anybody can change it. So that's what you have to. I mean, you have to like, it's a convention only, but you have to treat like that. Yeah, it's a constant.
Okay.
Okay, so we covered that very well. Okay, now let's think about the methods. Okay, like instance method, class method, and a static method. Okay, so instance method, anything you create a method like def. Okay, like this, it becomes like an instance method. Okay, and again, we don't have a public, private, those access modifier here. Okay, so anything become here. This is the instance method. Area, circumference in the instance method. So you can call with the instance. For example, I'm creating a circle, and I'm from the circle, I'm calling this this thing. Okay, it's very simple. Or anything. Okay, how to create a class method? If you're creating simple normal method in Python, then it becomes an instance method. Okay. If you want to create a class method, there are two things in Python. One is a class method and a static method. There are two different things. Class method and a static method. Okay. So anything, suppose you want to create at a class method. Suppose in Python, in Java, we create like what? Public, static, right? Static is a kind of class method, right? So in Python thing, how to create a class method, we have an annotation for that class method. Okay. So you have to use, you create a normal class, and you create a normal function. Okay. And annotate with the @ of class method. So now it will consume, it will assume that it's a class method. So we use annotation in Python world. Okay. So for example, here I have an employee, and I have employee count is a class level variable. Raise amount, it's a class level variable. Okay. Anything you're creating at the class level, it become a class level variable. Init is a constructor, we know that. And this function is a class method. Okay, using annotation. So this will become a class method. And on the class method, your first parameter should be always CL class. Okay, so it can be anything. Okay, but it can be X, Y, Z, anything. But it is a good convention again to always use CLS class. Okay, so always this is a difference. Okay, all the instance variable, always their first parameter is a self. For all the instance variable. Okay, for all the class method, the first parameter is always a class, CLS. So this is the difference. Okay, so from the class method, you can access your class variable like this. I'm trying to access class. Okay, you can also access from the class name also. Okay, or you can, because this class name is referring to the class. This CLS is referring to the class. Okay, self is referring to the current object, and CLS, this class, is referring to the class. Okay, so I can use class dot raise amount and class dot this. Okay, like this. The from strings a class method. Apply raise, it's an instance method. Okay, yeah. And also one more thing, class method we also use for creating object. It's kind of factory method in Python. Okay, for example, here in this class method, it is just like I'm just accessing the class variable. I'm assigning some data here. It's just assignment. Okay, and here I'm creating new object. You can see that I'm using return CLS. Okay, and I'm calling the constructor name and salary. So CLS, name and salary, passing it. So it will become like it will call it will create new object. So we can use class method for as a factory alternate approach, constructor factory method. So you can use also that like this. Okay. So this is a way to create a class method. So I have two employee and okay, how to suppose you create an object. So how to access the class method using the class name? For example, you can see that I'm creating two class, EMP1, EMP2. My name and salary, passing name and salary. I got two objects to reference. Okay. And now I want to access, set, raise amount, whatever. Okay. So how to access it using class name? Because class method, it is only for class. It is not for instance. Okay. So always you can use a class method you can use the class name to call it. Okay. For example, here also, for example, from string, I'm using class name dot from string, and it will create a new object. Okay. Apply range, it's an instance method, so I can use instance variable and apply range. Okay. And self keyword, you don't have to pass anything. Suppose here I have a self only, I don't have any parameter, so I don't have to pass anything. It's a without parameter. Okay. So this way you can create class method. And from the class method, you can modify the class variable. Okay. So when we use class method, let's suppose we have some at the class level, we have some object, something at the class level, we want to modify it. It is always best practice to use class method. So whatever change you will do from the class method, it will impact all the references, all the objects. Okay. So that's, so I find two purposes for using class method. One is for updating the class variable, and second is the creating another object like a factory. So this way you can use the class method. Okay, any doubt here?
Can we overload the constructor more than one?
More than one constructor?
Yeah.
No, it will not allow. Constructors will be unique. You're saying like this, right? Already we have an init method. So
Raj, method overloading is there.
Method overloading. Yeah, we have overloading. Method overloading.
What about overriding?
Overriding. Yeah, we have overriding. We have abstraction. We will learn later. So you're saying something like that. Suppose I can pass some different, right? Suppose I passing name, salary. Suppose what I can pass department, something, and city, something like that. I don't think it will allow. Let us say that. I've never seen this example where I have to very well. There are two init variable. I think it should. Okay, here's the line. Okay, two init. Okay, one name, salary, department. No, it would call name. Name.
I think
okay,
it's overloaded.
I think it is shadowing. I think it is kind of. Yeah, it is not considering this one. It is considering this one. It's not a good practice because I've never seen creating two init method.
Okay.
I think it will overshadow. I think it will not consider the first one, but it is not a good practice.
The reason why I asked, right? Normally for any object creation, we will not have every variables in hand during creation. We might need some values later. In that case,
yeah, then you can use builder pattern.
Yeah, correct.
The builder pattern you can implement in design patterns. You can implement here.
Yeah.
In that case. Yeah, so this way, yeah, and so we understand the class method. Okay, then there is a static method. Okay, so what is the difference between class method and static method? So class method use when you want to change something of the class variable. Okay, and its parameters would be always class CLS. Okay, So it is for two purposes. The first purpose is to modify the class variable or make some factory, okay? And this static method is more like a utility, okay? It has nothing to do with class or something. It is more like a utility kind of method. Just like in Java, we create like util methods, right?
So better they might have named as util method as an
yeah,
addition.
yeah. So we create here static method. Static method is more like a utility. It has nothing to do with class, okay? So it's a convention that a static method, so a static method don't access instance of class data. The class method can access the class variable, okay? But the static method, they don't access instance or class function, class data. So it's a pure static, pure utility, okay? You can create that like this. So this is always a convention. Whenever you want some utility kind of thing, you use a static method. And whenever you want some class level thing, like changing class variable, okay, then use a class method. So class method and a static method. So you understand what is instance method, what is class method, and what is the static method. Okay. Yeah. Okay, so when to use what? Okay, I have given some example here. So for example, suppose it's a database, okay, and it's a class level, okay, and in the constructor I'm creating, I have, suppose in the constructor I have to create some connection or I want to update database. So I have a username, I'm passing username email. So username email is instance variable, okay, and in the database I'm adding this user. I'm just adding one user in database, okay. Then I have update email. This is instance method. And I have a class method, okay. This class method, like it is accessing the class variable, for example, database using class. So this class just referring to the class, it is referring to the class, okay. So from the class, I'm trying to access something at the class level. So that purpose, use a class method. I'm trying to access something, okay. And class method here, again, I'm creating something new class. I'm creating a new user. It's a kind of factory I'm using it. So so class method, I find two objects, two purposes. One for accessing the class variable or changing the class variable. One is for creating some factory, creating some new object, okay. And a static method, I'm just doing some validation, some just simple check. It's just a utility function, okay. So let me run this. So I'm given some use cases when to use what. Here there's a problem. I'm using self. Is a static, it's a class variable. I'm using self. Let me run this. Okay, so if I create, okay, so I'm creating user and database. So let's suppose I'm creating one user, this one, okay. And from this user, I want to update email. So, okay, email will be updated. And from user, I'm calling from dict. Okay, so it will create a new user. So it's a static, it's a class method, and calling validate from email. Okay, let me run this. Okay. At the date, I want to access database. So, okay. So here, database. Okay. If you want to access database, suppose here, get user. Okay. Okay. Get user count. It is accessing database. Okay. So get user count. I'm calling it no, right? Okay. Let me call 1 second. Yeah, I'm calling it. Okay. Let me user count 2. Okay, fine. So here I'm creating 2 users, right? You can see user number 1, this user, Raj, another user, Alice. Okay. So I'm just want to get how many users I have in my database. So get user count, it's a class method. So from the class I'm calling this, it is giving me 2 user. So self database, okay. Let me call.
Maybe if you try to put the dictionary of the members, right, we can know whether it's creating a new database variable conditions or not.
It is always good practice to use class name, not self. because here, okay, class dot name, it will.
This should be okay. No, this is
Yeah.
this CLS data should be.
Yeah, because it is trying to access the class level.
Yeah.
So it will give the length of how many users are there. Or if you want to get the dictionary itself, list itself, okay, let me return the lists. Let me return the, so list, it will give the list only, right? Okay, there are 2 users. Let me print, let me loop it. I got 2 users. If I use a for loop, let me get the name in there. Okay, so I'm adding to Raj. Okay, I'm updating the email. Okay, first it was this and Alice this. Okay, if I use self here, let me see the difference. Okay, again, yeah, Alice. Okay, I'm getting 2 users.
But the difference I see is the email is getting updated when you call the update email.
Update email.
The previous site when you use constructor, the new at example.com is not getting affected.
Okay. If you use
yeah. Just wrap this. Yeah. Now, when you run now, right, the update email is not okay.
Okay. Update will work. It's working, right? It is updating also. So update email, what is that? It's instance variable, right? Instance is instance variable.
Yeah, it's okay.
New email, self-lot email. Okay, it's updating.
Anyway, I think better we can use
better always.
Class
limit will be better.
Yeah.
Okay. Yeah, so I give some example here just to use when. I give example of instance variable class method for accessing or updating the class level data, and static is only for validating. So it was a kind of example. Okay. So this is a rule of thumb. Instance method needs self. Always you need to pass self for instance method. Class method needs CLS, class data. It is referred to class, but it can be anything. Not only you can pass X, Y, Z, anything. Okay, but it's always a good practice. I mean, it's a convention to give a CLS. It refers to the class. A static method need neither to. It's a pure utility. It will not access class or instance. Okay. Okay. Yeah, so that's what we have seen. So we have, as of now, we have seen what is the class at the class level, at the instance level, private, protected, how to create methods, those things we have seen. Okay, let us see more things which are useful. Like creating, suppose you have some instance variable, you want to create setters and getters, just like in Java, right? So we have also here we can create setters and getters. Okay. But we have different approach. We can create multiple setter getter for each variable. Okay, for example, I have Celsius. For example, I have a temperature. I have a variable called Celsius. Okay, so Celsius is like a protect. You can see it's a protected. I'm using one single underscore, so it's become protected. Okay, so here, see they have some annotation called like @ property. Okay, so this will return something. So it's a good practice. And setters, we have a Celsius. This method name dot setters. It will set something. Okay, and deleter, it will delete something. We use delete keyword. Delete keyword is to delete some variable. Okay, and the property is for getter. It is more like we have like a getter in property. And if you want to set something using this keyword @ method name and setter, it will set something. If you want to delete something, we have a deleter. Okay, this way we can use it. Okay. But it's I think we have a better approach from this. So we call it, I think this is the better approach. Okay. if you want, suppose you have multiple property, okay, and I think this one. Yeah, so I think this is the best approach for setters and getters. Okay, so it is called factory. Okay, suppose but the problem here is that suppose I have multiple property. For example, in the product, I have a price, I have a weight. I could have 3-4 more property. Okay, so for each property we have to give setters and getters. Okay, so it will take a lot of code. It is suppose you have 10 property, 20 properties, and you have to write 10 corresponding setters and getters. Though you can do that, there's no any problem with that. You can do that like this. You can provide setters and getter for individual property. Okay, but we have a better approach here. We define a factory. Okay, for example, like this. So this factory create a local getters and setter function and return a property itself. Okay, so how it works? You just define a function. Okay, and pass a parameter, pass your variable. Okay, and here we in the Python we have a get attributes. It's very useful function, get attribute and set attribute. Okay, so you can leverage these things. So get attribute, how the get attribute works. Okay, you have to give the let's suppose this is object. Okay, and from this object what you want to get, what let's suppose we have an object. An object has multiple property. Okay, so I want to get any individual property. So you can use get attribute, pass the object, and pass that object that property name. Okay, so instance is the self of the class using the property. So this way you can get attributes. So this actually, it is internally it is calling getters. It is from this object it is calling the getters. So this function will return you the property of that function. And for setters, self object and new value. Okay, and you can set new value here from this object, the variable name and the new value name. Okay, and then return a property of getters and setters. Okay, and like this. For example, I'm giving example. For example, suppose I created this function. Okay, and let's suppose I have a product. Okay, I have multiple prices. I have, suppose in the product I have multiple variables. Okay, let's suppose I have a price, I have a weight, I have XY. I could have multiple properties, multiple things. Okay, so I will just create single function. Okay, and from the single function I will pass our property name. For example, price, weight. Okay, and this will do one second. Yeah, so here suppose I have a product. Okay, and I have multiple property. Okay, so instead of creating individual setter getters, I can create a common function like this common function, and in this common function it will handle both getters and setters. Okay, so here I'm just passing my I'm just passing the property name. Okay, and here I have a get attribute. Actually internally I'm calling get attribute, and I'm passing the self's current object. Okay, and the property name. So it will just pull it will give you the current property name, and this will just set the property name. So here I'm just basically I'm getting the property, I'm setting property. Okay, so instead of creating multiple getter and setters, I'm creating a common module where it will get and set, and these things I can call in my classes. Okay, so I'm calling that function. Okay, I'm calling this function, passing the parameter. Okay, I'm getting the price and weight. Okay, and this is my constructor, and from this what I can do, I can create my product. Okay, I can creating a product with price and weight. Okay, and I can get the price. Okay, and let's suppose I want to set the new price. Right now the price is how much? 2000. I want to set a new price like this, so it will set a new price. And if I want to get it back, so I can get new price. Okay, you can see that here I don't have to do setters getters, so it is making your code very modular, And though you can do that, you can, like this previously also, you can create multiple instance variable, you can do individual setter getters. Instead of that, you can create a common function, okay? And this common function will do all like setters and getters, okay? And you just use that function here. Automatically, internally, it is creating setters and getters for you. So it is removing a lot of code. Yeah.
Earlier you said, right, inside the class, if you declare any variable outside their function, it will become a class variable. But now we are declaring a class variable outside variable.
Can you come again? I don't get your question.
Earlier, when you want to declare any class variable, we have to declare inside the class,
Mhm.
outside the function. So it will become a class variable, right?
Yeah, this become a class variable. Okay, yeah, I have defined this function outside, okay, but I'm calling it. So this become like a, see here, I'm just calling the function, okay, but this price and weight, this becomes like a class. Yeah, it's a class variable. No, actually, what is happening here now? If you're doing like this, okay, like self dot price, okay. So basically, it will create it is trying to trigger the factory. It is trying to trigger this function basically. Okay, so here actually what I'm doing here, I'm just define a function outside, okay, and at the class level, I'm just calling it, okay, like price and weight. So here, I mean this function actually returning a object. So this is an object actually because it's returning a property, okay. So property is an object. So it is this price and weight is like an object for me. And from that, I can set the price. So here I'm setting the price actually. I'm calling the setters here, okay, and setters will wait here, and then I can access it. So your code become very, modular way. You don't have to create multiple setters and getters. This is one approach. There are more advanced approach for that, okay, like this, for example. This is one approach. This is one of the approach where you can create a function and return a property. Okay, set a get property, and from this property you can access it. This is one approach. Second approach is that more advanced. It is called descriptors. Okay, this approach is called factory. It is called property factory. Okay, so instead of creating your, instead of creating multiple setters getters by you own, you create a function. So basically, what you're doing, you're creating a function that will build a property for you. So creating a common function which will create setters and getters. This is what you're doing basically.
Okay.
Okay. Yeah, it will. If you do practice, it will come. For the first time, maybe it might be confusing. But right now, what you're doing here, so I have either I can create multiple setter getters, okay, but the code become very verbose, okay. The approach is that I can create a common factory, okay, and here it will do all the operation for getters and setters, and it's an inbuilt property, okay. Actually, basically, I'm using get attribute and set attribute. So get attribute is an inbuilt function, global function in Python, where you can get the attribute. You have to pass the object and the property name, okay. For example, let me show you how the get attribute works. So basically, I'm using.
I understand these two are coming from the built-in, and this property, this factory, is the one which is going to create an object inside the class data.
Yes.
Okay.
It is going to create the object for you, okay, and it is giving you getters and setters, and that what
So though we are declaring outside that function, it will become internally a property of the class.
Yeah, it's an output function, but here I'm using it. It's become a class level. I'm declaring at the class level. Okay, it's become a class level. So whenever in the constructor, when I'm setting anything, okay, it will call automatically this function. Okay, this is how the Python work. Okay, you just practice it. Okay, this is one approach where you can create a common function to handle all the setters getters. Okay, another approach is the descriptors. This very advanced property. While a property it is called property factory. Okay, is a function that returns a property. Descriptor is a dedicated class that implements this descriptor protocol, set, get, delete. Okay, so here what we do, let's suppose here also we call it, okay, so this is my main class. Inside the class, I'm creating a class. This is my class. So this class will handle the like setting and getting and deleting. Okay. So I'm creating a, suppose I have a, let's suppose I have a product class. Okay. And product has a name, price, and weight. Suppose I have 3 attributes. Okay. So one approach, simple approach is that I can create 3 setters, 3 getter, 3 setter for name, one for price, one for weight, individual for all 3. Okay. This is first approach. Second approach is that I can create like this. I can create a common function. Okay. And here I can use I can use get attribute, set attribute, and here I can call here I can call that function. Okay, for price and weight. This is the first approach. And the third approach is like this. Okay, so here we use set this. Okay, this one get underscore underscore. These are the inbuilt function. Every object has this inbuilt function. Okay, so we are leveraging some inbuilt function. For example, underscore underscore get, it's an inbuilt function. Underscore underscore set is an inbuilt function. It's a getter function, it's a setter function, and set name. It is also a function. It is automatically called when the class is defined. Okay, so this getter is called when you do, whenever you're calling, suppose you're creating object and calling any property. Okay, so basically they have actually how the Python work. They have given you inbuilt function like setters, getters. You need just override it. You just give an implementation. Okay. So I'm creating a class, and in that class, I'm overriding set get function and set function. Okay, and in the get function, you have to pass the instance variable self. Okay, and instance variable and object type. Okay, actually, object type is, it can be optional, so you have to passing the instance. Okay, and instance and value. Okay, so here get I'm just passing if instance is, I'm just checking instance is null, then return self. And then again, see, I'm using get attribute. Okay, so from get attribute, I'm passing the instance. Okay, and I'm getting the that object. Okay, so here this is what I'm doing here. So self, actually you have to, actually we are overriding these 3 functions basically here. So this way it becomes getter and setters. Again, we have instance and value. Okay, and here I'm setting, I'm just doing some validation here. And again, I'm calling set attributes. Earlier also, we use the same thing. We use get attribute and set attributes. Okay. Here also, we're using get attribute, set attribute, but we are overriding these 2 functions. This is an inbuilt function. So if you override these 2 functions, get and set, okay. And now suppose you're creating a product, okay. And you're creating, you're calling this, suppose I have a price, I have a weight, okay. So here I'm calling for the price, I'm calling it, okay, so it will set, it will, for the price attribute, it will create a getters internally, and it will create a setters internally. And also while setting up, it is doing some validation, okay. So this is a use case. Suppose you want to create instance variable, and you want to create setters and getters, and at the same time, you want to do some validation while setting the data. So you can use this approach, okay. So here I'm creating one price, one weight, and I'm passing here mean. It is taking some mean value, max value. I'm giving some value here. I'm just passing that value, and internally while setting up, it will do some validation, whatever you want to perform, okay. And when I'm doing, when I'm in the constructor, when I'm calling set.name, okay, set.price, set.weight, basically it is calling setters internally, because I have defined here, okay. And then this is what it's doing. So either you can use this approach, or I can use this approach.
We are not passing the variable name anywhere now. In the valid quantity, we are not passing the variable name, price or weight.
No, we are passing only this value. This price and weight we're calling in the constructor. Okay. Here, here I'm just passing. Yeah, we don't need to pass here price. I'm just passing the. I mean, suppose I want to get a price with some minimum value that I'm passing here. For the weight, what can the, let's suppose I want to get some object with minimum price or minimum weight and maximum weight. That's I'm creating right now. Yeah, you don't need to pass up property here. I'm just doing some validation here. Even suppose you don't pass anything. Okay, suppose I don't pass mean and value. Okay, even though it will work. I mean, If you don't, suppose you don't have to do any validation, only setters, getters, then you don't have to pass the value. So you can remove this, okay? Maybe it will create setters, getter basically without passing the name. Here you don't have to pass the name. But if you want to do some validation, some with data, you can pass that. Are you getting my point?
Yeah.
So I can remove this. Let's suppose you have something that you want to validate while creating the variable. You want to validate, you can do that. Otherwise, it's optional. If you don't have a validation, you can. I mean, this is not required. Basically, you can remove this also. Okay. So here we don't have to pass the variable. You can pass the data, and this way you can do that. I know that maybe it's first time it can be confusing. You just practice it around it. Okay, then you will understand. So this way we handle if you have multiple property in a class, multiple setters, getters. The very simple way is create multiple setters, getter. The first approach I show right this way, create multiple setter getters. Okay, but the code become very verbose. So if you want to remove this, create a factory function like this. Okay, you have to pass it, but here you have to pass the property name, and it will create a getters and setters. Basically, it will creating a setters and getters for you as an object using get attribute, set attribute. Okay, so we are using get. Just do some research about this. What is get attribute, set attribute? So it will create. You have to pass the object. It will create in the object. From the object, you can get property. You can set the property from object. So that's what we are leveraging. You have to pass the variable name. Okay, and then this one I'm using in this context. Okay, I'm using in the context of product. Okay, so the object here for this function will be product. The self. Okay, this will be a product for this function because I'm using in this context, in the product context. Okay, so for product, I'm passing price. So for the product object, it will create a setters for price and getters for getter for price. So this way I can create multiple setters, getters per property, and my code become very simple. I don't have to create multiple setters, getters. So the setters, getters creation, that logic is handled by this object using get attribute and set attribute. This much I'm doing right now. Okay. So if you understand this, flow, what I'm doing right now, for each property, I'm creating setters and getter a separate object, and that object will handle how to set, how to get. So my code become very simple here. Okay, and rest part like initializing the object, like initializing the instance variable, and calling, creating the object, getting the object, setting the object will remain same. So the setters getter will be handled by this this function. Same thing I'm doing here, but I'm using set name. I'm using this inbuilt function set get and underscore set. I'm passing self instance and I'm doing some validation. And but in this case, you don't have to pass the variable name. Okay, you just create multiple. Suppose you have a price, weight, just called it without property name, and you will have a price and weight. So, and all the like validation, like setting, getting will done by these two objects. Okay, so you just practice it. Okay, I will suggest you just try this, just practice this, how to control multiple setters, getters, either first approach, this approach, or using set underscore get or underscore set, these two approach. Just do some practice around that. And important thing is the get attributes. Let me show that how it works. This is I think we use multiple times get attribute and set attributes. This is a very important function in Python. Okay. So get attribute function is a Python inbuilt method used to retrieve a value of a name attribute from object dynamically. It provides a safe alternative to direct dot notation access by allowing default value. So this one, for example, any code is they've given. So this is you will find a lot of instances of this code. Okay, for example, here, yeah, suppose I have a person class. I have some name, some age, some country. Okay, get attribute, pass the object and age. Okay, so if you want to get the age, okay, so it will create a getter for you. Get attribute for this object. From this object, I want to get page. Okay, and I want to pass on default. If the page is there, then yeah, so it will create. I mean, it is creating a getters and setters for given objects. You don't have to, for example, here in the person class, I'm not creating any setters and getters explicitly. Okay, so who is creating that? This function is taking the that responsibility to create getters and setters. Okay, so refer this. This is very useful function. We use a lot of times. Get and set attributes. These are inbuilt. It's a global function. For example, I have a student. I'm creating a constructor. I'm creating a student. Okay, and I want to from student. I want to get name. Okay, so I'm calling get attribute. Okay, I'm passing the student reference. It's my object. Okay, and which attribute I want to get name. Okay, so basically you're calling a get name. Okay, you're not declaring in the object here. You don't have to declare any setters getters, but still you're using it. Okay, so this way you can use this function. So just try to build some understanding about get attributes, set attributes. It is very useful. Okay, so that's what this Python is leveraging. So internally they are using set attribute, get attributes internally to create and setters and getters. Okay, just build some understanding around that. Just try that these two codes. Okay, and it will be not very difficult. Okay, I hope you're getting it right. I hope you're not getting bored. These things, I know that for the first time it will be very strange, but you will find it comfortable going forward. Okay, so
maybe once we used to had hands-on, right, it will be
yes,
comfortable.
Yes. Yeah, even for the first time, I was very feeling very awkward. These things because if you come from Java background, it's feeling very awkward here. So, but if you do practice, keep doing something coding in some assignments, some practice, and it will become easy. Okay, so as of now, let me recap what we have seen. We have seen how to create class. Okay, how to create instance variable, how to create a class variable, how to create instance method, class method, static method, difference between class method and static method using annotation. Okay, and how to use instance variable, protected variable, and private variable. What is a static, what is the class level of variable, class data. This thing I have seen. And how to handle multiple setters and getters. Okay, and in order to handle setters and getters, you can create multiple setters and getters. This is also fine, but the code becomes very verbose. So for that, we have a factory function. Okay, and we can use that factory function to create setters and getters. And your main class become very clean. You don't have to create setters and getters. There will be a factory function which will handle to create setters and getters. For example, you can see that this class will become very clumsy. You can do a lot of setters getters. For example, in even Java, right? We use I think we use one library.
Lombok.
Lombok. We use Lombok, right, to manage the setters getters. If you use Lombok, your class become very clean. Only just declare the property name and all the setters getters being by some other thing. The same thing I'm doing here. I'm not writing all the setters getter in my class itself. I'm using some utility, some module, some other function, which will handle my setters and getters. Like you are using Lombok here. It is more like a Lombok.
Okay.
So you're creating a module like a Lombok, this factory function, which is working as a Lombok in Java. So just practice it, okay? And the main brain is the get attribute and set attribute. This is the main brain, which is doing the data stuff for you. Okay, so practice this. This much we have seen, okay? Yeah. Okay, so in this class, we will see about inheritance. Okay, in previous class, we have seen about how to deal with object, how to create objects, like their different property, how to set the property, how to get the property, their instance variable, static variable, right? How to deal with them, how to create setters, getters, how to create some factory. Well, creating factory is optional. If you can create, otherwise you can use of get attribute, attribute. But if you want to make your code modular, you can do that. Okay. So this much we have seen. I hope you're getting some idea about basic about how to create class, right? And how to create the object from the class. Those things you're getting some basic idea. So in this class, we will see next chapter about inheritance. Okay, so how the inheritance work in Python. So inheritance, I hope you know what is inheritance, right? So inheritance is it's a kind of reusability where you have some you have some base class, you have some super class, and from the base class you want to reuse some property. I mean, you don't have to start from scratch. Already something is there, and you want to reuse the property, you want to reuse the behavior. Okay, I hope you understand what is inheritance. I'm not covering in detail about what is inheritance. I'm assuming that you know that. Okay. So in the Python world, if you know some other language like Java or C++, then you have idea how to do inheritance. So in case of Python world, inheritance is how to handle inheritance. It is also very similar. Okay. For example, here I'm giving some simple example of single inheritance. Okay. So there are multiple types of inheritance. It is a single inheritance, right? It's a multiple inheritance. It's a multi-level inheritance. It's a hierarchical inheritance. There are multiple types. I hope you know that. So in the single inheritance, we have just, the setup is like this. We have one super class and one child class. It is called single inheritance. Okay. So what is the structure? What is the code for inheritance? It's very simple. First of all, we have to define a super class. For example, this is a super class. So I'm defining an animal class. It has some constructor. Okay. And it has some behavior, some function, like this is an animal. It can speak, it can move. Okay. And here, if something you don't want to give the body, or you don't want to define anything, you can give a pass here. Okay. For example, here speak. I'm assuming that speak is more like there's no body of it. Okay. So here I'm if somebody tried to no, I mean it is. I mean, I'm giving here not implementation here. Yeah. So subclass must implement it, or otherwise you can do just pass. Simple is, you don't want to give a body, just do a pass. Okay. So right now it has no body. This much you can do. Okay. So we have simple setup or super class. Okay. And I have a dog class. So this is an animal, and because dog is a kind of animal. Okay. So it's an inheritance tree. I hope you understand what is the inheritance tree. Okay. Yeah. So we have to follow that tree structure. So we have an animal and we have a dog. So dog can extend animal, or dog is a animal. Is a property. Okay. So dog is an animal here. So that's why dog is extending animal. So how we use extend? So in Python world, we don't have extends keyword or implements keyword. Okay. So how do we do that? We use with the symbol. So create a class called, like dog. Okay. And if you want to extend any other class, then in this parenthesis, okay, you have to give a parenthesis and give that class name. So this becomes this code is saying that dog is extending animal. So this is how we write in Python. If you want to extend any class. So it is because this dog is extending single class. That's why it's a single inheritance. Okay. So that yeah. So this is the syntax for inheritance. Then I'm creating a init. I mean, even my child can have its own constructor. Okay. I'm creating a constructor in my child. Okay. And I'm overriding. So for example, this dog is getting some function from animal, which is speak, right? So what is the inheritance? It will inherit. I mean, for example, this is speak function. Okay, this dog is also have a speak function. Okay, so this dog is not creating this speak function is coming from its parent. This speak function, and here the dog has a liberty to make some change, or write its own body, or override, or give some different implementation. So that's what this this speak is doing. So in the speak, I'm just writing my own function on functionality. I mean, how the dog will speak. Okay. For example, cat. So cat will speak in a different way. Okay. So like that. So you can create a multiple child, and you can provide, the child will provide its own implementation of how to speak. Okay. And the fetch it's coming from the child itself. So fetch is not coming from superclass, because there's no fetch in superclass. So you can create, so the child class can create its own method, or it can inherit from the parents, or it can override the method from the parent. So this is a very simple setup, like of single inheritance. So we have a parent class, we have a child class, and this is the code. This is the syntax for extending or creating the parent-child relationship. Okay, and we have to give init. Okay, this is simple setup. And yeah, I will talk about constructor here. Okay. So, and here, one thing you will notice here that here we have a super keyword. Super is a kind of method which refers to parent class. Okay, in Java also we have a super, right? So in self, self refer to current object, okay, and super refer to parent object. Okay, so here I'm explicitly calling the super init. Okay, in the Python world, how the constructor calling or constructor chaining work, I will discuss right now. But you can call it explicitly. You can call it the super constructor. So here I'm explicitly calling the super constructor. You can call it, or you can I mean, you can avoid it. No problem. Okay, but there's a relationship in Python. I will talk about that. So here in this code, I'm just calling my super constructor. So what it will do, it will just create the instance, I mean the name, whatever name you're creating here. So the super will contain the name. Okay, it will initialize the name variable. Okay, and then okay, and then even if you initialize the name variable in the animal, so dog will inherit that. Okay, so dog will have the name, and breed is its own. So breed is not coming from superclass, it is its own one variable. So now dog has now two variable. One is the name variable, which is coming from superclass, and breed its own variable. Okay, so I'm calling explicitly. If I don't call explicitly this init, if I don't call it, okay, I will show that. Okay, what will happen? Okay, so let me run this. I hope you got this simple setup, right? How the syntax is working, how the things are there. Any question, any doubt here in this simple setup? It's very,
No, it's clear.
I don't think it should be difficult. Okay, so let me run this. There is one change here I will talk about. Okay, so here I have an animal, I have a dog. Animal is extending, dog is extending animal. With dog have two property, name and breed. Okay, and here how to call it, how to use it. Okay, so here I'm just creating a dog object, right? So from the dog object, because the constructor is taking two parameter, name and breed, so I'm passing name and breed. Okay, so okay, so dog will contain these two variables, and then after dog I'm calling its property, this method, like I'm calling speak, I'm calling move. Okay, so this speak will I mean, it will come from here, right? It's implementation. And move like dog has no any move function, right? There's no any move, they have only speak and fetch. But this move is coming from superclass because dog is inheriting that behavior. So this move is coming from it is inheriting. Okay, it is, I mean, it does not own it, but it has inherited from the its parent. So that's why you can call move. Okay, because move is there in the parent, so it is getting from the parent. It's simple inheritance concept. Fetch, so fetch is coming from its own dog. So because fetch is there. Okay, so this way we can create simple inheritance and simple call it. Okay, and then also for checking, we have some global function. It is very useful function, is instance. Okay, if we want to check whether this any object, any reference or object is the instance of any class. Okay, so this
want to use the identity operator is instance, or we have to only use this?
Which operator? Is operator.
Identity is operator, because that is also checking for reference, right?
No, is operator you can check for memory, right? If the both objects are pointing to same location.
In this case, both are different memory, but hierarchy is the same. Yeah. Okay.
I want to check the instance, whether this dog is an instance of that class or not.
Okay.
Suppose you have two instances, dog one, dog two, and you want to check whether both are pointing to same object, the memory is same, then you can use is operator. And dog one is dog two.
Okay.
Okay. So here I'm checking whether this dog, what I'm creating this dog is a reference, right? It's an object, and this dog, this dog and this animal is a class. Okay, so I want to check whether this dog is a reference or instance of that class.
Okay.
So is instance is a global function. We use that. So in instance, we're passing our reference and the class. Okay. So here I'm checking whether this dog is the reference of dog. Yeah, it is that, because dog is a dog, so I can say that. I'm checking whether dog is an animal. Yeah, because it's inheriting, right? So dog is also animal because it's inheriting. So dog is a referring to animal. Okay. Yeah, and also there's is subclass. I want to see whether dog, this is a subclass of this or not. So I can use each class, this subclass. It's very, I don't think it's very difficult. So, but these are very important utility kind of function. Sometimes we have to check whether I'm using the same, I'm using the right reference or not. So you can use in each instance. Okay. This much is the very basic thing. Okay. Now, one thing I want to talk about constructor chaining. Okay. If you know in Java, Java has a cool feature about constructor chaining. So once you create, suppose you have a super class, you have a child class, right? Let me talk about that. I hope you know what is constructor chaining concept, right?
Yeah, by default it will call the default constructor.
Yeah,
We
yeah.
don't call.
So suppose we have a super, this is super class and this is a child class. Okay. And it is inheriting from, this child is inheriting from parent. This is my parent class and this is my child class. Okay. So it has its own constructor. Suppose it has constructors in it, it has own constructor. Okay. So what the constructor chaining does, so if you're creating any subclass or any child, okay, so if you're defining a constructor in a child class, right? So this child class, if you're creating the instance of child class, then the constructor will call the child class constructor will call the superclass constructor. So there should be a chaining. Okay, that's the concept in the Java world. If you know that concept, then it will relate here. Okay. So in the but here the problem here is that what I find that I'm giving one example. Okay. For example, this let's understand with example. For example, here the animal. Okay. So animal has a init. It's a constructor. Okay. And in the constructor, I'm just initializing some name variable. Okay. And then I have a dog, and dog is standing animal. Okay. And I'm just doing pass. So here I don't have a constructor. Okay. So if here, what is if I create? Okay. So how the Python works? Okay. So if you don't, in the child class, if you don't creating constructor, okay, then the Python, it will call the super class constructor. So if the constructor chaining will work here, it means, okay, if you're not creating constructor explicitly, without constructor, the child has no constructor, then Python will call the super constructor explicitly by its own automatically. Okay. So Python look at the animal. This is what I'm writing the comment here. Python looks at the animal and call its init. I mean, if you don't giving any init, don't giving any constructor, then Python will call it. Okay. So here, if I'm creating a dog, okay, creating a dog object, okay, and passing the name. Okay. So because this name, because dog has no constructor, but dog is calling the constructor of animal. So that's why this name will go into here. So it will call the constructor with the name instance variable, and this name will get initialized. Okay, so this name will be available to dog as well. So that's what I'm doing. Dog, I'm giving name. Okay, then I'm calling the name. Okay, I think this much you got. Okay, so why I'm able to call the name, because because the child constructor is able to call the parent constructor, and it is done by Python itself automatically. I mean, the constructor chaining is working here. Okay, in case if you're not creating constructor. Okay, let us see this scenario. Okay, so we have an animal and it has a init, and it has a constructor. Dog, it's a child of animal. Okay, and and here I'm defining constructor. Okay, in the previous case I was not defining any constructor. So if you don't define any constructor in the child, the constructor chain will work and it will call the super constructor. Okay, but as soon as you create your own constructor, okay, then Python will not call super constructor. I mean, constructor chaining break here. In case of, if you come from Java world, then you know that if you're writing a child constructor, and then by default compiler insert super or this keyword, right? So I think in case of Java, the chaining always happens. Whether you do it or not do it, it will always create a super in the child constructor. It will put in a super. But here, in this case, if you're creating a constructor, okay, So Python stop here. It will not call super init. So constructor chaining will break here. Okay. So as soon as you add init in the dog, the subclass, automatic linking of the parent constructor is broken.
Okay.
It will not happen. So this is your job, your responsibility that you have to call it. If you don't call it, then the parent, whatever it has, the parent things that will not get initialized properly. So this is your responsibility. Okay.
So once we override any constructor, then it's our responsibility to create an
So we are not overriding the constructor. We just
not override.
calling it.
Once we start declaring any constructor,
Yeah.
it's our responsibility to call
Yes.
super.
Yes. Yes. So here Python is not inserting super by default. Okay.
Okay.
In case of Java, if you just create a constructor in shell, if you don't call super, then by default it inserts super.
Okay.
But here you have to do it. You have to. I mean, this is as a developer, this is your job to maintain the constructor chaining in Python world. This is your job, not the compiler or interpreter job.
Okay.
Okay, so that's the difference. Okay, so here just for demo, I'm just, for example, this animal has a name. Okay, and dog has a constructor, and it is taking name and breed. Okay, and here you can see that from the constructor of dog, I'm not calling super constructor. I'm not calling it. Okay, I can call it. This is your job. If you want to call it, you can call it. If you don't want to call it, maybe this is your responsibility. This is your headache. Okay. So now I'm initializing breed. Okay. Now here I'm calling dog. I'm creating this object dog. I'm passing name and breed. Name and breed. Okay. And here, now tell me if I'm calling, I'm passing name here. So this name will get initialized or not? The superclass.
No, it won't. No, we didn't call.
Won't. Yes.
Yeah.
Because I'm not calling super constructor. So this name will not give never initialized. Only breed will get initialized. We are doing this initialization, but for name it won't, because the chaining is not working here. It is broken. Okay. So that's what I'm want to demo here. I'm creating a dog object with name and breed. Okay. And here I'm trying to call the name. So it will say attribute is not there. Right. Let me run this. Let me show you. I hope you got this demo, right? Understand this?
Yeah.
So I called the dog, so this got printed, okay, and breed got initialized. Then I'm calling the name name attributes, okay. So name is in the dog, name is not there because this name has not been initialized, okay. So that basically saying dog has no attribute name, okay. So if you want to initialize it, then you have to, this is your job to do it. So you have to do super dot, you have to call it explicitly init and pass the name. Okay, so constructor chaining is your job, your responsibility. That's what the funda is. Okay, now name is coming. Okay. Name is buddy. Okay, name is coming now. Parent is called. Okay, so this is your this is what I want to demonstrate here. If you don't call it, then the chaining will not happen. So this is your job. If you want to initialize it, you have to call it explicitly.
Okay.
Okay. So in Python, the rule is you define init in the child class, you hide or block. This is your job. Okay. If you're not giving you're not calling it, then you're hiding it. Okay. You're blocking the parent init. So Python assume that you want to take the full control of initialization process. So it won't do anything behind your back. So this is your job to take the full control. Okay, so this is what the important thing I wanted to talk about, how the constructor chaining work in the Python world. Any doubt here? This concept is clear?
Yeah, clear actually.
Okay. Okay, so other than this, all the concepts like single inheritance, like multiple inheritance. I mean, there could be multiple inheritance as well, like this. There could be a class A, right? Class K, class B can extend class B, class B can extend class A, then class C can extend B. Like it can be a multiple level. That is also possible. Or there could be a class A, right? And there could be hierarchical approach, right? Like A, there can be B, B can extend A, C can extend A, D can extend A. It's called a hierarchical inheritance. These all things work same way, okay? No much difference here. The code, I think you understand the code. The same thing, you can write the
So
code here.
hierarchical and multi-level is okay because it's all applied in Java also, but multiple is
Yes.
not there. Right?
Multiple, yeah, that's what I'm coming right now. So Python has a very nice feature of multiple inheritance. So that I wanted to talk about. Okay, so this is case. Let's suppose I have a class A, okay, and class, it is called diamond problem, right? So how the Python solve a diamond problem? So suppose I have a class B and class C. Okay, so suppose class A has some function called C, S or C, some C. Okay, so class here, class B is also extending class A, and class C also extending class A. Okay, and here I have another D function, D class, which is inheriting both. It is also coming from B, it's also coming from C. It's a typical diamond problem. Okay, so this C is also in the B, this C function is also in B, and C is also in function C. Okay, so this D, how will this D will resolve? Because the C function are in the both the classes. It is because a multiple inheritance is allowed in Python. Java Java does not, they do not allow it. Java does not support it at all. But Python support it multiple inheritance. One class can extend multiple class, which is not possible in Java world, but in Python world, it is possible. Okay. But the problem here is that how to resolve this diamond problem, this typical problem. Okay. So for example, this B has a say function and C has also say function. So both having the same function, say and say. Let's suppose, okay. So this say is coming from B. Suppose D is trying to extend B and C. So say is coming from B also, and say is coming from C also. So as a person, I'm confused here, right? So which one, which say I need to accept? I need to accept from B or C. Okay. So how this is pretty typical diamond problem. So how the Python solve it? I hope you understand the problem statement, right?
Yeah.
So this is a typical problem statement of diamond problem with multiple inheritance. So that's why Java does not support it, but how the Python support? Okay.
So this applies to both variables and methods, right?
No, with both
Variables and methods. It's just
yeah,
variables.
yes, right. Yeah. It applies both. Okay. So Python has a unique way to handle it. Okay. So I'm giving one example. Let's understand with the example first. Okay. For example, I have a mammal one class and winged mammal one class. Okay. So here, and this bat class is extending both class mammal. So how it can extend both class? This is the syntax. In the parenthesis, pass the class name. Okay. So this means that bat is extending both the classes. Okay. But here, because both the classes have a different function, so there's no any here typical use case of diamond problem, because it have different signature, different methods. So I think it is not a problem here, right? So mammal has a mammal info, and this class has a winged animal info. So the method number are different here. So it is not a problem here. So I'm creating the bat.
One confusion here, Raj. Since we are extending from two classes, right? Which need to be called? Because in the earlier example, if you don't create any init, right, it will call the superclass init. But now we have two superclasses, right? So which need?
Yeah, so it is not you are not giving any init here, then it is not calling any init here. It will not call superclass init, because here there's no initialization, right? I'm not initializing anything here. No variable initialization happening.
Okay.
But it will this property will come here, right? This method will come here. If you're doing some initialization, then you have to careful about constructor chaining.
Yeah, constructor chaining will not happen if you are overriding init in the subclass.
Yes.
But now we are not overriding, so I think both the init will be called if we declare in the parent classes.
Yes.
Okay.
So here I'm creating a bat object, okay, and then here I can call, okay, this what I'm trying to demo here, that I can call this two methods because the names are different, so it is not a typical diamond problem. So I can call it, right?
Yeah.
I can call this function also. I can call this function here. It's a typical. There's no any problem right now, okay? But the problem is like this, okay? Suppose I have a class A and class 2, class 3, okay? It is a typical diamond problem. So class A is a superclass, and class 2 and class 3 is inheriting class 1. Let me draw that. So here, this is the class A. Okay, this is class A. This is class A, and this is the class 2, class 3. Okay, class 2 is inheriting class 1, and class 3 inheriting class 1. Okay, and there's a class 4. This is my class 4. This is class 4. So class 4 inheriting from class 2, and it is inheriting from class 3. So typical diamond problem, right? And it has all the same name. You can see it has a method name M. So it has also name method name M. It is inheriting from here. So it got M. It also got M, same method name. And now this is also inheriting class 4, inheriting class 2 and class 3. So it got also M. Okay. And here I'm not overriding something. I'm just inheriting it. Okay. So this is the setup. Okay. So now question here is that because here, because class 4 is getting the M from both, from class 2 and class 3, it is inheriting from both. Okay. If I'm call M here, okay, then which M it will consider? It will consider from class 2 or class 3. It's an ambiguity, right? It's a kind of dilemma, or it's kind of ambiguity problem, right?
Yeah.
That which one I need to consider, because this M is coming from both cases. Okay, it's coming from class 2 as well, coming from class 3 as well. So which M it will call it? Okay, so that is the typical diamond problem. So how it solved the problem here is, it is called MRO. Okay, so Python is a concept called MRO. You can search it. It is called method resolution order. Okay, so it has followed one typical, very simple solution. The solution is like this. I like this solution very pretty much. So what it does, it start from left to right. Okay, it check whether this method are there or not. Okay, first it will start from itself. Okay, for example, I want to call M method. Okay, so I need to do a lookup whether this M method are present. First it will check itself whether in the class 4 itself has M method. No, in this case class 4 has no its M method, right? It is not overriding, it's doing nothing. Okay, then first it will go at the first it level. Okay, but it will check whether in the class itself it is the method is there or not. Okay, if it is not there, then it will go from this. Okay, it will start from the left side, go to the right side. Okay, so first it will go to the class 2. Okay, so it will check, okay, in the class 2 M is there. Okay, M is there. Okay, so it will got it, and it will stop here. Okay, let's suppose here I don't create anything. Okay, I just put a pass here. I just create a pass. Okay, suppose class 2 is not defining M2. Okay, so it will start from class 2. Okay, class 2 has no M. Okay, no problem. Let me go to class 3. Class 3 has, okay, class 3 has, it will come from class 3. So this is how it handled very smartly. So this is called method resolution order.
Once you define pass with its implementation, right? Pass will definitely call, right? It will call the M of class 2, right? We should not.
Yeah, it will inherit, but it has not defined it, right? It will just inherit, but it has not defined its own, right?
No, what will happen in this code, in the exact code, in the class 2, if for the definition M, instead of printing it, can we declare pass? What will the output are?
In class 2, right?
Yeah, in class 2, in the print statement, instead of print rate, this.
Yeah, suppose I don't write this. Suppose there's no any M method.
Okay. In this case, it's clear, and now it will go to class 3.
Yes. Suppose I just want to pass. Okay. Okay. Let me do it 1 second. Let's suppose if I do like this. Okay. Suppose I don't define it. I just do a pass. Okay. So class 2 has not one thing. Class 2 is inheriting from the class 1, but it is not defining. It is not writing its own class on M. Right. So it will go from class 2 to class 2 has no M, though it's inheriting, but it has not written its own version. So it will go to class 3. So it will print class 3 here. Okay. This is how it works. Okay. But let's suppose if I define my here, maybe here itself in the class 4 itself, I define it like this. Okay. So it will start from lookup will start from itself. Okay. So because M, I'm calling M, so it will check whether the class 4 itself has the M or not. It will find it is there. Okay. Then it will use it, and it will not look up for class 2 and class 3. It will not go to that level.
Okay.
So it will come from class 4. Okay. Got this?
Yeah, clear.
So this is how it manages the This is how it manages the multiple inheritance. Okay.
So the control is with that formula MRO, right? We can't control which class to go.
No, this is a rule. They start from the left side.
Okay.
This cannot control. If you want to, you can swap it. Okay, suppose you want to call from class, you can do class 3, class 2. But this is a rule. They start from the left to right.
Okay.
So this is one example. I have given some cases, examples when the method is overridden in the both classes. Okay, so in the both classes, class 2, class 3, it is overriding. Okay, but class 4 is not overriding, so it will consult class 2. Okay, this is one case. Case 2, when the method overridden is only one class. Thus, I think this already explained. Yeah. For example, class 2, it is not overriding. Okay, it is not overriding, just inheriting it. Okay, class 3 is overriding. Okay, so class 4, it will start from itself. It will not find M, then it will go to class 2. Class 2 has also no implementation. Then it will go to class 3. It will print class 3. It will find the class 3 like this. Okay. Let's suppose all class define the same method. In the class 1 has a M its own version. Class 2 has its own version. Class 3 had its own version, and class 4 had its own version. Okay. Then it will start from the class itself. How it works. The lookup will start from class 4 itself. Okay. It will find it. Okay. I have something. Then it will use it.
Okay.
Okay. This is how it works. Okay. And here I'm giving one example here, calling method of parent class from the child class. Okay, here two things here. It is okay. Class 1, it is giving its own version. Class 2 is overriding the class method. Okay, and it is calling the super method also. I mean, it is overriding the method itself. Okay, and also calling the super method. Okay, just to get something. Okay, so this is one case. And class 3 also giving its logic and calling from its super class. Okay, this is how you can call it super class. And then class 4 is also doing the same thing, and it is calling from class 2 and class 3 both.
But this way of calling is kind of class method calling, no, not a method, right?
Yeah, we're calling the method, yes.
But normally for class method, we need to pass argument say less, no? When you directly call any method from using class reference, we should have the argument as say less, right? Yeah, it is self.
That is for class method. If it is something is a class method, then yeah, the first thing is we pass the CLS for class method. But this is not a class method. This is a normal.
So in that case, we in the subclasses, right, we have to call this reference only, right?
Yeah. Also, we can see this. We can also call super here.
Yeah, that's what I'm thinking.
Super also you can do that. Okay. So this class 1 referring the class, actually you can do super also. Both are same as you just calling the super basically.
Oh, okay. Super makes sense, but class 1, I think it's
super work super.m. For example, here I'm calling super and calling m. No, super is a bit different. It works a different way. Super. One second. What I wanted to show a difference about the problem here with class 1 with this class approach. Okay. So if I run this, so what happens here? So it will call this because the lookup will happen here. It will call the m here from here. Okay, class 4, and then let me run this, and it will call from super also. So first it is calling from class 4. Okay, and then it is calling from class 2, coming into class 2. So it's printing this one coming from class 2, and then it is calling from class 1. Okay. Again, it is for then it is calling from class 3. I hope you understand that it is calling classes and calling class 1. Okay. So it is calling multiple time class 1. And the super class, with this approach, it will call multiple times super class, because I'm using class here. Okay. I'm using the class dot this method, so it will call multiple time class. But in order to avoid, that's what I want to do, so that you can use super in order to do that. If you're calling a super like this, okay, like super dot method like this, so it will not call, the super get called, the extreme super method will call just one time. So it is calling, it will call this method class 4, okay, and then it will call class 2, then class 3, and then it will call class 1 and at the last. This is what I wanted to show here. Now this is how this, if you put super here, that's how it is going to behave.
This two not clear, Raj. The previous one and current one, because
This one?
Yeah.
Okay. Here I want to see the demo. Okay, what is the if you're using a super, okay, if you're using super in the child class, okay, how it's going to behave. And if you're not using super, if you're just calling the super class method, okay, so how it is going to behave. Okay, so how the super works, that's what I want to demo here. Let us understand for a super, how the super works. Okay, so super in Python, super function in Python is used to call a method from the parent class, especially in the multiple inheritance. It helps avoid explicitly naming the parent class. I mean, from the parent class name also I'm calling it, but you don't have to do that. Ensure proper method resolution following the MRO and prevent duplicate call of the same method. Okay, so here what is happening here for class, for example here, from class 4 I'm calling class 2 and class 3. Okay, and from class 2 I'm calling class 1, and from both I'm calling class 1. So class 2, let me draw this.
I just understand. So now
Understand,
we
right?
are class 1 is getting called duplicate.
Yeah, so class 2 is class 1 getting called 2 times. Okay, so here if I'm calling it, so here I mean this class will get called 2 times if using this approach. If you want to avoid the duplicates, then you can use super. So super will so with the help of super, it will not call duplicates.
So before calling it, you find the memory map and remove the duplicates. Right? That's what you're highlighting.
Yes. So it helps avoid explicitly naming the parent class. It ensures the proper MRO and prevent the duplicates call. Okay. For example, let me print here object. There is a dot. There is an MRO property here. You can see how it is resolving.
I think you type MRO, right? MCR, right?
Okay, MRO. Okay. It should have MRO, right? Object. It is a method. There are it's a D dot, okay, class, we call it class name. Okay. Class 4, okay. I want to see the class 4 class level. Class 4, right? Class 4 dot. So class 4, then class 2, starting from class 4, then it will go to class 2, then class 3, then class 1. This is the class 4 MRO. We also can use MRO here. So class 4, it is calling class 4, then class 2, class 3, then class 1. Okay. So with this, I can see the lookup, how they're looking. What is the MRO lookup? You can see that with this MRO property. So here I wanted to say, give a demo that you always use, whenever you're using inheritance, it's always good practice use super. Okay.
Okay.
That's what I wanted to give a demo here.
No, we can find the difference because when you use super, right, the duplicate cost getting avoided by the Python and stuff.
Yeah.
You understand, it's clear.
Here I'm giving more example. It can be a tricky one. Let us understand this. Let us understand. For example, here class A, it has a greet function. Okay, returning A. Okay, class B is extending class A. It is also a greet and calling super. It is returning something and calling super greet. Then C also coming extending A, also calling super, and D, it is extending B and C both, so it has two parents and super D. Okay, so here how it's going to print here. If I call, let us see the MRO first. So this is the MRO for D. D for B is C and A. Yeah, this is the things. If I create a child class D and call the greet function. Okay, so how it works. So greet function. See what happens. First, it will print this line, okay, and then it will call B because the resolution will start from B to C, okay. So it will call. Okay, I'm calling here super. Okay, because I'm calling here super greet. Okay, so because I'm calling super here, so who is a super of B? D, B and C, right? Both in B and C. So it will go into B and call the greet of B. First, it will go into B. Okay, starting from left side. Okay. So going into B and calling its greet function. Okay. So it returns the B. So first it will print D, it will print this line, and then it will print this line. Okay. And it will not call, then it will go to C now. It will not again call to greet A. Here it will stop, okay? Because I know that here I want to see who's the parents, okay? For D, who are the next parent? Okay, so for D, I have two parents, B and C. Okay, so that's what super is doing. Super is checking its parents. If you're using super, then in the inheritance tree, it will check your parents. So for D, we have two parents, B and C. Okay, so first it will go to B. C, from the B, I can go to A also, because from in the B, I have a super, right? So from the B, I can go to immediate A. But here, what will happen, because I'm using, because D has two parents, okay? So the super will check immediate parents. Who is for the D, who is the immediate two parents, B and C? Okay, so first it will go to D, okay, then go to B, okay, B, it will go to B, and then it will go to C. So you can see let me run this. So that's what I wanted to demo here. So yeah, this is what it is printing. You can see that DBCA. Yeah. Okay. So what is happening here? See, first I'm running it.
I was expecting a different order, DBA and CA, but now.
Yeah. So B, you can see after DC. First I run this grid. Okay. I'm calling grid. So resolution, lookup has done. Okay. It has called the grid of D. Okay. Because D grid is there. So this line got printed. This line got printed, and it is going to super. Okay, so super, who is the immediate parent for D? B and C, right? So first it will go to B, so it will print this one, B. Okay, so here it is not going to immediately A. So here a stop here, then it will go to it will go to C, who is a parent. After B is a C parent, then it will go to C, this thing, and then ultimately it will go to A. So here A is not, it is not going A two times. It is not calling duplicates call. Okay, so this is, I just wanted to show a demo that super is always look for immediate parent, and this way you can avoid. Suppose you have multiple. For example, B and C both are calling A, right? Both are coming from A. If you're using C, it will not call two times. It will go just one time, because it will just call the immediate parents of D, B and C, and then it will stop, and then it will go final A. So it's one sequence here I wanted to demonstrate. This is how the super work.
Clear, but one thing surprising, right? Your thing return B concatenation of supergated. So I'm surprised how this breaking the calls and keeping the pending call in memory and calling super and then see. That's what I'm surprised.
Okay.
No, that line is not in it. No, what I was highlighting to that is not in it. The syntax line. Return B, not in it. Yeah. Return D super read. So in the current line, it's trying to call either B or C, but surprisingly,
Yeah, in the current line, it is calling B and C.
yeah, B and
First,
C.
it will go to B. It will print this one. Okay.
Yeah,
And here it will stop. It will.
yeah, that's
You,
what
okay.
stop
You might be
the-
thinking that. Okay. You might be thinking it will call D, then go to B. It should. I mean, expectation is like this. I know that. What you're expecting? You're expecting like this.
D hyphen B hyphen A and then C
D
hyphen A.
hyphen
Yeah.
B. B then hyphen A, right?
Yeah.
A. That's what you're expecting, right?
Yes.
And then C hyphen A. This is what the expectation you're expecting.
Yeah, it's not expected, but surprisingly,
Yeah.
the A is getting called only once.
So this is what super does. If you do the previous call like this using the class name, then it will do it 2 times. Okay. But if using super, what the super does, it only check that this is the concept here, that if using super in the child class, okay, it will go to the immediate parents. It call the parents. So for the D, it has 2 parents, B and C. So first it will resolve B and C, and for B and C, there is a single parent A. Okay. So it is finding the next immediate parent. That's the concept here. Okay. So for the D, who is the next parent? B and C, right? So that's why super, if you're using super grid, so it will go to B, find the grid. Okay, find the grid, and whatever here that, okay, and then it will not go to super of A. Okay, because here I want to resolve who's the parent for it is finding the parent only for D right now. And then it will find the parent for D. Suppose it found that for D, I have 2 parents, B and C. And then it will find the parent for B and C, which is A. So this is how the super works. That's what I wanted to explain here.
Okay.
If you want to call multiple times, then this is the, this one. You can call class, this one. Okay. So yeah, it's a bit confusing, but this is what you have to put the concept that if you're using super in the inheritance or child, then super will always call for immediate parents. So this is the concept.
So if a class has 2 different two parents, right, it'll keep the calling pass and it'll execute the mother only once.
Yes.
So,
It will call the only once. Yes. It will remove. It will not call the super parent 2 times. That's what.
okay.
It will call the immediate parent for B, and then it will stop there, and then it will call just 1 time. So it is not going 2 times to the parents, the supreme parent. It is going just 1 time.
It's clear.
Okay. Yeah, it's a bit tricky. These are tricky ones.
Yeah.
Okay, that's I cover here. Otherwise, if you want to go 2 times, then you can use the class name that will go 2 times. So this is what super does. You can do a research at how the super works in the multiple inheritance and the child. You will find that super is just not calling the methods. Okay, it's just finding the parents. And this is how the MRO work with the super. Okay, so just remember this concepts, this trick, that if you're using MRO and you're using super, and if your class is calling multiple parents, 2 or 3 parents, 3 parents, then this is how it works. It will go to the immediate parents, it will stop there, then it will go to the ultimate parent. It will not call multiple calls. So this is what the concept here. Yeah. So let us understand this code. So we have a class A, it has hello, printing something. Class B extending class A. C is extending class A, okay, and then D, okay, D is extending both B and C and doing pass and calling B and D hello, okay. So which hello it will call? D has no hello, right? So it will start the resolution. So it will go to B.
Yeah.
So B, come to here, then it will print hello from B. That's what a simple code here. So I've given some example and you can try this, okay? Yeah, for example, the same thing, okay, super, okay. Here also, let us see, I have a base class in it, printing something, okay. Then left side, it's standing base in it and calling super. See, I'm calling super, okay. I'm calling super super method. Then right side, again calling super, and bottom or again calling super, okay. And here I'm creating a bottom object and calling the value, okay. So here, yeah, so how it, if you're calling the, I mean, you're just creating the object of bottom, okay, then it will call all the inheritance, right? I call all the constructor, right, init, okay. So here you can see the, I mean, how what it will print. So you can see that for the bottom, it has two immediate parent, left and right, okay, because I'm using here super, okay. So first it will print bottom init, okay, because I'm super here, so super will go to the next parent, so which is left. So left, it will again print left int, okay. Again, I'm using super, it will stop here, then it will go to the right print, and then ultimately it will go to the base parent. So bottom init, left init, right init, and the base, if using super. So this is how the super resolve. This is how super works with the MRO.
Okay.
Okay. Yeah. Yes, there's some tricky one, but this is how you have to remember this trick. The super, how the super resolve the MRO problem.
Clear, Ashish. Clear now.
Okay. Otherwise, it's yeah. Otherwise, the concept is very. This is the concept that it resolve from. Do the lookup. You have to understand how the lookup happens. That's what you have to understand. Lookups happen from left to right, and first it will start from itself. If it is fine, that it will not go to the lookup. If it is not finding, then it will start the lookup from left to right. So this is the MRO concepts. Okay. We try this. Okay. I had written. I'm giving a couple of examples here just to demonstrate. Okay, so this is the inheritance. Other than multiple inheritance, all this other different inheritance like single inheritance, multi-level, these all things are pretty much straightforward. The way we deal with. Okay, only thing you have to remember the constructor chaining, that you have to careful. Whenever you're writing constructor, you're doing initialization process. Okay, and you have some variable to initialize. Then you have to be careful that you have to manage. I mean, the constructor chain is your responsibility. You have to call the super constructor if you want to initialize something in the super class. So that's the funda that you have to remember. Okay, if you're not giving init in the child class, if you're not calling super init, then it will not. I mean, Python will not do any initialization process for you.
Okay.
This is our job. So this is how the constructor chaining work, how the multiple inheritance work, how the MRO work, and how the super work with the MRO. Well, this is the pretty much concept in inheritance. Okay, let us talk about abstraction now. Any questions here? I hope you're getting.
Yeah, it's okay.
Yeah. Now let us talk about abstraction. So in as we know that what is abstraction? Abstraction is something hiding some behavior implementation. Okay. So how to handle abstraction in Python worlds? It's not very difficult. It's very easy. So we have a couple of concepts like how to do abstract method, concrete method, property, and class initialization. Okay, let us understand that. So I think abstraction is pretty much same as Java. There's no much difference in abstraction case. Okay. So, but for the abstraction thing, if you want to create any abstract method means there's no body. I mean, there's no implementation route. It's a pure abstract. Okay. So if you want to create anything abstract without, I mean, you want to tell that it's a pure template. It is no body right now, no implementation right now. Then we have to use one model called abstract method. Okay. There is a ABC. ABC is called abstract base class. So it's an inbuilt class. Okay. Abstract base class. Okay. So you have to import abstract method from ABC. So ABC is an inbuilt library. So it's a class basically. So you have to import from ABC, import abstract method. Okay. And ABC. So ABC is a super class. Okay. So anything you want to create abstract, you have to extend ABC.
Okay.
So I'm creating a shape class, okay? And this class is extending ABC, okay? And here I'm defining my abstract method, okay? In order to define abstract method, you have to use this annotation @abstract method and define your function, normal function, okay? Area, self, and keep it pass. You don't have to give any logic here, okay? This is how we create abstract. For example, here I have a shape, which is abstract, creating area and defining with abstract method, creating parameter, self, pass, and so they are okay. So these two things, area and perimeter, are abstract method, okay, but describe is a concrete method. So in an abstract method you can put both. I mean, you can have either abstract method or concrete method, both, or only abstract method, okay. So here area and parameter are abstract method, but describe is a concrete. So I have given the logic here. You can see that here I'm not using @ of abstract method because it's a concrete method. Okay. So this how this is the only logic. This is how we create abstract method in Python. Okay. So this is my one abstract method. Okay. And now I need to extend it. Okay. This shape is containing abstract method. Okay. Anybody there could be some implementation, some child who will extend the shape and provide the logic for how to calculate area, how to calculate parameter. Okay. So here I'm creating a circle. So there could be multiple type of shape. It can be circle, it can be rectangle, something like that. Okay. So circle will extend this shape. This is how we're doing class circle extending shape. Okay. I'm creating my init method. I'm writing some installation logic. So radius, it is initializing radius. Okay. And it is extending area. It is inheriting area and perimeter, these two function from superclass, shape class, and it is providing the implementation. Simple logic. Okay. So extend this abstract methods from superclass and write your logic, write the body, how you want to calculate area, how you want to calculate parameter. This is your logic. Okay. It's become a circle. Okay. And this concrete method, it get inherited. Okay. Or you can also, if you want to override it, you can override it. You can write your own logic, but it's just like a shadow. You are not overriding it. You're just shadowing it. Okay. But these two methods are overriding. We are just inheriting and overriding it. Okay. I can create another.
Again, I can repeat the last one.
Yeah, suppose describe here, right? Describe the concrete method here. Okay. So here in this child, I'm not writing the body or writing any logic for describe. Okay.
Okay.
So if you want to do that, suppose if I want to write here that I want to give a different thing of describe, I want to describe my own way, you can do that. Okay.
Yeah, that is not overriding. That is just
yes,
a shadow.
Yeah. Okay. But that is not the overriding basically.
Yeah.
That's what.
Okay.
Just a shadow. You're doing a shadow basically. Okay.
But here, if you don't override the area or perimeter, right, will you get any issues in the runtime? Because both are declared abstract, right?
Yeah, so you can do a pass here, not a problem. If you do a pass here.
No, pass is okay, but if you completely omit area definition, will I get any issue in the runtime?
Okay, I mean, you're not doing anything, right?
Yeah,
okay.
if we comment the entire method.
Okay.
Either
I
one.
think, it's a good thing. Yeah, because it's, I think it should, 1 second. Yeah, it will give error, yes. Let me run this. If I create one child class, suppose XYZ, you're saying like this, right?
I just completely removed anyone. Yeah.
Okay. And
Okay.
Passing radius, suppose 3.
We don't have any implementation, right? So I think, yeah.
Can't without it will stop your runtime. You can't do that. So I mean, it is expecting that because it has abstract thing, you should override.
Okay, it's clear. Okay. So it's a must to override. I mean,
It must override, yes.
Okay.
You cannot instance create object of abstract class without implementation. Yeah, it's a rule. It's a
Okay.
runtime. They will give error. So
Okay.
it is must to do it. So it is abstract. Okay. So I'm creating circle. I'm overriding it, and creating rectangle. I'm overriding it. Okay. And then then how to use it? Just create the object of circle and rectangle. Pass the instance variable. For example, radius and here width and height. So same time doing creating a circle, creating a rectangle, and calling the circle and describe. Okay, this is pretty much simple. The way we do in Python and Java, same thing we do here. Okay, so this become my abstract method. Okay, and how to implement the polymorphism? Same thing. You just define a function here and pass the reference, pass the variable. Okay, anything. For example, shape. Okay. So this shape right now, this shape is complete abstract. There's no concrete, there's no implementation. So here I can pass anything. I'm just defining it that I have a shape. Okay. At the runtime, I can pass circle, I can pass rectangle.
Okay.
Okay. Other thing.
This argument is needed. I mean the type.
Yeah, this is not required. This thing is not required. If you want to remove this, no problem. Circle is not defined. Okay, let me define it. The type is not in Python. Type is not mandatory.
Yes, from
Okay,
but
but
now understand.
Yeah, but it's a good hint, kind of. That's good practice to give a type. But Python is not very strictly. It is checking that it's what type it happens at the runtime. But it's a good practice to give a type hint as a hint. Okay. So this way, I'm just creating passing a shape here, and at the runtime I can pass any kind of implementation. So this is how we could achieving the polymorphism. Okay. So this is the concept of abstract, and for abstract, if anything is an abstract class, you cannot instantiate. You cannot create object directly. Okay. For example, let me create an object. So for example, shape.
Already
right?
there an example you already commented out. This will fail. Yeah, here in the middle.
Okay. Yeah. You cannot create the object. Okay. So if I create object of shape, it will stop you. I think already I'm given that. Yeah, it will not allow to create. I think logic is same as Java here. Abstract is simple here.
Okay.
It will give you error. Okay. You cannot instantiate abstract class super without implementation. So you cannot create the class of super abstract class.
The only thing which I see is difference, right? We all achieve the Java topic using keywords, but here we are importing a different module to implement the abstract based class.
Yes.
Okay.
Okay. And a couple of things, polymorphism, and you can also create concrete class. Concrete class are fully you can, for example, animal, the move, it can have both abstract function or concrete function, no problem. And how to create an abstract property in abstract method. Okay, so for that we create. We have to use property and abstract method. Okay, like this. So define a property in Python. You have to combine. We have to combine both at the rate of property and abstract method. Okay, and create a method here. Okay, and just give a pass. Do not define it. Okay, so it assumes that because you're giving property. Okay, so this will assume that area become a instance, area become kind of variable. Abstract, that is abstract.
That apply only for methods, no, not for variables, right?
No, you want to create some abstract instance variable, like abstract property.
Oh, really? Because in Java we don't have any concept called abstract property, right? We have only abstract methods.
Yeah, right. In Java, property, they have final, there's final property, but here we have a property, abstract property.
Oh, okay, nice to see.
Yeah, we defined with property and abstract method. Then the child, for example, here, square. Okay, I have a shape. I have some area. Okay. Right now, I don't know what is the area. Okay. So square, it's extending shape. Okay. And I'm giving some side here, and here here I'm creating a property now. Okay. So for the area, okay, the value for area become this, whatever you do calculation.
Okay.
So you're defining one property in the abstract method, okay, which is not, they don't have any value right now, okay. So in the subclass, you can extend it and you can give a value like this. So the child will give any kind of value that depends upon their calculation. So yeah, it's a new, this is called abstract property in Python world.
Okay.
Okay. And you cannot create object.
Yeah.
And also there's just setters also. You can create abstract method with setters. Like we have abstract method and property. So it becomes like a property, abstract property. If using abstract method like setters, then it's like a setters. You can set it. For example, I'm creating a property here. Okay. And here I'm just setting the value here. Okay. This thing we generally don't use much thing of these things, but yeah, I just added here. And also it can have like in the abstract method, it has a property. It has a setters. It has a static. In the abstract method, you can define a static method and class method. It can be new for us. So, for example, in ABC, this is my class abstract class. Okay, here I'm defining abstract method. I'm saying class method. Okay, so actually the child will inherit this. Okay, they will provide the implementation, and for the child it become like a class method. Okay, so you are creating a template. You're giving a kind of contract or template that this is going to be a class method for the class for the child. You're doing that. Okay, you getting this?
Yeah.
So I'm creating, this is abstract right now. I don't have a logic right now, but it can be, whatever the child will extend it will be a class method for the child. Similarly, for static method, I can define a static method in the abstract method. So the child will inherit it, and for the child, it becomes a static method. Okay. And this is an abstract method. So abstract method can have a class method and static method. For example, I have a processor, and the child who is going to process, who's going to implement this method become a class method. For example, from class, it becomes a class method for this class. It will pass class, and from the class it can create object, or it can refer to the class variable. A static method, this is like, for example, this process becomes it's become a static method. So this becomes a static method for child. Okay. So in the abstract thing, you are just giving a template that this is the template, this is the function, but it is going to be considered as a static method or class method for the implementer. This is what you're doing basically.
Okay.
Okay. So we see how to create abstract method. You have to write this annotation. And logic is pretty much same, and you can define abstract property there, and static method there, and class method there. Okay. In Python world, there's no interface. Okay. In Python, in the abstract class itself, you can define both concrete and abstract method, but there's no such interface where it's a pure abstract, because this abstract thing is not pure. You can define both. You can define concrete as well as abstract thing, right? It's not a pure abstraction, okay, because you have some concrete also. So there's a concept called interface. So Python has no intercept concept. There's no intercept kind of
we can
things.
actually easily, right? Once we declare all are abstract, then it will be an interface.
Yeah, right. You can define everything abstract, then become abstract, but it also allows to add concrete things.
Understand. Yeah.
Okay. But there's a concept in Python protocol. Okay, it had been added in 3.8. It is not in all Python. So, but you have to import it. Okay, it is not the inbuilt feature. Okay, this all thing is not the inbuilt feature of Python, but You can try some different, like there's a protocol. So protocol become like it is more like a very strict kind of interface. Okay. So how the protocol, you have to just, for example, you have to just extend the protocol. Okay. And here all the methods, if you're extending protocol, then you cannot give any concrete methods. Everything will be 100% template or abstract. Okay.
So
And
dot 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 is the syntax, right?
yeah, this is a syntax. So here it is, I mean, it's a pass. I mean, there's no body if using protocol. So you can use protocol for implementing interface. Otherwise, you can go with that approach, create abstract class.
If you go with abstract definition, then it's possible to have it complete, but to avoid this,
Yes.
you can go for protocol.
Yes, right. So here you cannot do implement any concrete thing. It will be all pure abstract. Okay. So this is what I have given there. Okay. And yeah, and overloading in Python, there is no method overloading. Okay. Overloading means you can define one method and you can pass different parameters. For example, I want to add, right? I can add to int, I can add to float, I can add to string, like that, right? It's a kind of method overloading. So in Java, we have a concept of overloading, but in Python, there's no method overloading. There is a way for that. I mean, in build, they don't have a feature inbuilt feature, but there's some workaround. You can achieve that, but there's no any I mean direct way to do that. Okay. So Python does not support method overloading by default. Okay. For example, suppose I'm creating product here. Okay, as name, and I'm passing two parameter. I just want to multiply numbers. Okay. So here I'm just trying to mimic overloading concept. So I'm passing two parameter and then passing three parameter. Okay. And here I'm multiplying two numbers, multiplying three numbers. Okay. What will happen if you create multiple function with the same name? It will just override, or it will just, it will hide the previous method. Okay. If you define multiple methods with the same name, only the latest definition will be used. I mean, it is going to hide, and the previous thing it will ignore. So it will at the runtime, it will only consider this function. It will ignore this function. Okay. So if you're calling, multiple times, you're creating multiple function with the same name, but different parameters, then it will ignore the previous one. Okay. For example, let me run this. For example, if I created two function with the same name, here I'm passing two parameter. I'm just trying to call this function. Okay. I'm just trying to call this function. Okay. So it will not work. It will not understand. Okay. It is asking that it is missing one parameter. Okay. It means that it is accepting, or it is just understanding this function. It has only this function. Okay. So at the runtime, what happens? It will ignore the previous function, and it will only consider the latest function. So in that case, we cannot achieve overloading. Okay. So, but in order to do that, we have some workaround. Okay. We don't have a direct way to do that overloading. So you can use this one. You can use this approach, like, you have to put some logic. Okay. You have to give some logic here. For example, guys, recording is going on, right? I have started recording.
Yeah, in my screen, it's showing recording only.
Okay. Okay. Yeah, so there's no overloading concept in Python direct way. So in order to achieve that, you can use variable argument concept. Okay, and as we know that with the single star, I can pass any kind of parameter, 1 parameter, 2, 3. It can accept any kind of parameter, and it will go into tuple, right? For example, same thing. If you want to implement this, I want to create a product function which it can accept multiple parameters, 1, 2, 3. Okay, so here I'm giving example that. I'm just actually, as a user, I'm just building this logic. Python does not supporting directly. I'm just building my own logic to mimic the overloading. So here I'm passing data types, and I'm passing argument. Okay, and here I'm checking. Okay, I'm just building my own logic. Okay, that if it is int type, then okay, then response is this, and whatever argument I get, okay, I'm just just adding it, okay. If it is an int type, then it will, then it becomes int because I'm initialized as an int, okay. So it will just do adding, okay. If it is a string type, then I'm creating a string, initializing with an empty string and then adding, because plus I can do on both, right? Plus, if I do string plus, then it will do concatenation, right? A plus B plus C, it will do concatenation. If I do plus on the integer, it will do summation. So I'm just leveraging that plus operation, and here I'm just building some logic here, okay. There's no direct support, okay. Yeah, but there's one concept in Python which they don't have a native support, but you can achieve overloading with the help of this called dispatch concept, okay. You have to import a library for that. Again, it's not an inbuilt library, inbuilt feature. You have to import third-party library. So there's a concept called multiple dispatch, okay. You need to install it, and with that annotation, dispatch annotation, then you can achieve it. Okay, so here for example, here I'm creating a product with multiple parameters, so 2 parameters, 3 parameters. For example, here two parameters, 2 int, then 3 int, then float. Okay, this is a typical overloading concept, right? So I can achieve with the dispatch. You have to use dispatch, then it will understand. But natively, there's no native support for that. Okay. Yeah, so this much we have covered. I hope you're getting this right. This overloading concept. There's no native support, but they have a workaround for that. Or either you can build your own logic. If you want to mimic overloading, you have to build this logic like this. Okay. In Python, there's a concept called operator overloading. There's no method overloading, function overloading, but there's an operator overloading. Okay. So we can perform overloading on the operator. Okay. So for example, here I will cover the next. I have a next file also. So for example, I'm giving some example here. For example, suppose I have 2 objects, okay, and I want to perform like I want to multiply 2 objects, okay. I want to multiply 2 objects. I want to add 2 objects. I want to add. Suppose I want to add 2 objects. I want to add 3 objects. I want to play with the objects, okay. So I'm playing with the operator here, okay. I'm passing different parameter to operator, and I can do that. So in order to do that, we have to use some magic. Now there's some magic function in the Python, okay. For example, at the rate of this one add, we have multiple operator kind of function like add, subtract, multiply. You have to override that, okay. Create a class, and you can put some magic function there, and that way you can achieve operator overloading concept. I will cover in the next chapter, okay. There's a lot of magic function in Python that is very useful, okay. So this much is about the object-oriented concepts which I cover, okay. Okay. So in this class, let us understand some magic methods. Okay. So as of now, we have already seen the object-oriented part, that how the object-oriented things work in Python. Those things we have already covered. Apart from that, there are a couple of few functions, inbuilt functions, okay, which are very useful in some cases. Okay. That's if you're building any object-oriented concept or building project in objects, then you should know how to utilize those inbuilt functions. Okay. So let us understand a couple of functions here. Okay. First of all, in the Python, everything is object, as we know that, right? So all the classes, whatever you're creating right now, they have a super class. Okay. There's a stream super class that is called object. Even in the Java also, we have a super class called object. Okay. So even in the Java, in the Python world also, because everything comes from object, okay. So if you're creating any class, okay, like this, any class, okay, so by default, they are going to inherit from the object class, okay, by default, okay. But right now, when the Python 3 started, we don't writing any, we are not writing explicitly that we are extending any object class. It happens by default, okay. So I have shown some example here. For example, before Python 3, we used to write this. We have to explicitly tell that this is the object. Okay, it is doing the inheritance. But right now, just once you create in a class, then by default, you have to understand that you are inheriting from object. Okay. And there are some function. If you want to see that what are the different function of inside the object, you add a function. You will find a lot of things which are coming from object. For example, equal, format, greater than, get attribute, a lot of things, hash, init, the constructor we are using, it is also coming from superclass. Less than, okay, new, reduce, okay, there are a lot of things, size of, str, okay. So this is the things, it's come from superclass, okay. And yeah, so let us see a couple of functions which are useful function, okay. For example, object creation and object representation, okay. So we know that we use init function, okay. It's again a inbuilt kind of function which is coming from superclass, okay. So whenever we need to create object, we have to use init. I think we have already seen that, okay. And representation, okay, there's a representation function, underscore repr, okay. So it is for developer friendly representation. So suppose you have some object, you have some property in the object, and you want to display, you want to put a representation, you want to show that how the object should look like, okay. So if you know the toString, right, in Java, so this is a toString basically, str, okay. This is the toString function where it will give a presentation of your objects. So this is up to you how you define. This is up to you how you want to present your objects, okay, when you're doing a print, okay. Then we have a format function. So representation, str, these two functions are for representation purpose, and format is for a custom formatting purpose, okay. This format when we use f, okay. So whenever you're using f, this is called f style string, okay. So whenever you're using f function, then this function is getting called, okay. It is called f string format. Whenever you're using format, suppose you got some object, you want to format it, or you're using f string, then automatically this is up to you how you want to format. If you want to give a specific format, then you need to override this, okay. You need to give a logic, okay. This is what I'm doing. For example, let me give example here. For example, this is vector class, okay. I'm creating the object of vector because it has a constructor, so I'm calling it, okay. And for example, I want to call representation, okay. So representation is an inbuilt function, okay. So I want to represent it. So if you're calling representation, okay, it will call this function internally, okay. If you don't give implementation, then object had its own way. It will go with the default implementation, default presentation, okay. If you want to present it to a string format, you can do str, okay. So this str is it's a kind of constructor. We have already seen, right? We have an int str, we have a dict, we have a list, right? We have multiple kind of function which do a typecasting or factory function, right? So same thing I'm using here. So this str will, if you have given some implementation of str, then it will reuse that function. It will call this function, okay. So basically, I'm just creating the representation of my object. So if you want to customize that logic, that how the presentation will look like of your object, then you can think about overriding these functions, okay, in that case. Okay, next is the operator. We can do multiple arithmetic operation on objects. Suppose I have multiple objects. I want to add 2 objects. I want to do subtraction. I want to do multiplication. That thing I can do in Python. It is called operator overloading. Okay. So if you want to do that, you have to override couple of magic function. For example, these are the function which come from, you have to override. Okay, it's a global inbuilt function that you have to override. It coming from object function. So there's an add function, underscore add. Okay. So if you're giving this logic, then you are giving the logic that how to add 2 objects. You're customizing the logic that how to add your objects. Okay. How to subtract your objects. For example, I have a vector and it has 2 instance variable, X and Y. Okay. And I'm saying that I want to add, suppose I'm creating 2 vectors. Suppose I'm creating two objects, vector 1, vector 2. Okay. And I want to allow addition like this, plus operation. Okay. So how this plus will happen, how these 2 objects will get added, that I want to customize. I want to control that. Addition I want to control. If you want to do that, then you have to override this function. For example, add. Okay. So here what I'm doing here, I'm passing two objects, self, the current object, and other object. Okay, this object, current object, and this is the other object. Okay, and here I'm I'm for the plus, for the adding thing, I'm considering the x. I'm just adding 2x, self x and other x, okay, and y other x, self x and other x, okay, and creating vector. So this is up to you. This is completely developer logic, how you want to add. This is completely yours logic, okay. For example, how to add, how to subtract, how to multiply, okay, these things, how to do how to do scale, how to do multiply with some scalar, okay, how to do division with some, I have some scalar, I want to divide by some number, how to do absolute of the number, how to do negative of the number, how to do equal. If you want to apply, you want to do double equal, okay, you want to do, you want to allow that this object can be used in the double equal, okay, comparison operator, then you have to this logic, okay. So there are some couple of operation logic, okay, and this way we can achieve operator overloading. So if you have to apply this logic, you can write these functions, okay, like this. So for example, I'm creating two vectors here, I'm adding two vectors, vectors as a class object, I'm adding two objects, I'm subtracting two objects, I'm multiplying two objects, I'm dividing two objects. So this is all logic you have to provide, okay, this is all thing you have to provide. For example, if I create a person object, okay, class person, okay, this is my person object, okay, it has name and some age, okay, and I create two objects of it, okay, P1 and P2, okay, suppose two objects, okay, and then on this object I want to add P1 plus P2, P1 plus P2. So how it is going to behave? Okay, because it's not supporting right now, okay, right, because I have not given the implementation for add. Here basically I'm trying to achieve operator overloading. I want to try two persons, two objects, okay. So by default, it will not allow. If you want to multiply two things, it will not allow, because I have not given the logic. Okay, you got this things. So if you want to allow that in your program, in your module, or in your case that your objects can be multiplied, your objects can be added, your objects can be divided, your can be, I mean, you want to apply some arithmetic operation on the objects, then you have to provide this logic. I hope you're getting the context, right? So these things becomes useful in that case. If you want to allow operator overloading, then you have to give this logic. Okay, then we have a comparison operator. Suppose you want to compare two numbers. You want to compare two objects, less than, more than, less than, equal, this all thing. Then again, you have to provide logic for that. Okay, so there's a call total ordering. It comes from function tool.
But
okay,
we already had arithmetic operator equals, right, to compare two objects, right?
Yeah, that is for equal. No, equal. You can do for inbuilt function. For example, you can do for int. You can do for string, right? These are inbuilt function, right? They are inbuilt object.
Yeah.
So this inbuilt this inbuilt function, this inbuilt of object, they provide this implementation. I'm talking about the custom object, okay?
No. Here vector is a custom object, right? For this we are overriding the equal method. So what is the difference between this one and total ordering?
Yeah, total ordering is for comparison, less than, greater than. Oh, okay, this one, right? You're saying this one, right? Okay. Yeah. This is also, I think, here. No, this total ordering is for less than. Okay, it is for less than, greater than.
Oh, okay.
This is for this one.
Auto generated. Okay.
They will auto generated. Okay.
Clear.
For example, I want to do less than. I want to do less than, greater than, less than, equal, greater than, equal. Okay, this one. If you're already equal, then it is it will take your logic. Okay. This is whatever logic you're doing. Okay. For the custom object, okay. See, for the inbuilt object, they have already, Python has already given this logic. how to do comparison, how to do I want to do a comparison with two string or two number, two float. Okay, so they have already given this logic, but you're dealing with a custom object, then you have to write this logic. Otherwise, you cannot perform arithmetic operator or comparison operator. If you want to allow that your custom object is also supporting these things, then you have to give logic. Okay. So total ordering is that you have to override, and these things you can, they can auto generate, or you can give the logic here. You just go through this file. Okay, it's not a very deep concepts, very simple things here. Okay, and yeah. And for the comparison thing, okay, suppose one thing I want to cover is it's a bit concept here. Suppose you have multiple suppose in a class, in an object, you have multiple properties. Okay, and in the multiple property, you want to apply some like comparison or some operation. Okay, suppose you have two, three property, and you want to apply. For example, you can see that in the version I have three things. I have a measure, I have a minor, I have a patch. Okay, I have three properties. Okay, and here in this three property, I want to apply equal. Okay, so how I can apply equal on these three things? Okay, so in that cases, I have seen a lot of cases. Tuple is the great example. Okay, so you can see that I'm creating a tuple. This is tuple. Okay, I have two objects, self and other. Okay, so I'm creating a tuple of self, this object, measure, minor, and patch, creating a tuple, and other for tuple. Okay, and on this tuple, I'm applying this logic, all the arithmetic operation like double, equal, less than. So that's what I'm written here. Tuple, you can apply all the arithmetic logic on the tuple. How it is useful is it is useful in case your object, your class has multiple property, and you want to perform some operation on the multiple property, then you can use tuple operation. You getting this point? So yeah. Tuple operation becomes useful in these cases. Okay, so how the tuple operation works? Suppose here it works by element by element. Okay, suppose I have one tuple 1 2 3. I have one tuple 1 2 4. Okay, and I want to perform less than. So how it works? It will go the element by element. For example, it will check the first element 1 and 1. So 1 is less than 1. No, right? Then it will go to second element 2 and 2. No, 3 is less than 4. Yes, true. So it will check 3 and 5. So it go element by element. Okay, if it is fine that if it is true, I mean it is fine that it is true, then it will stop here. Okay, for example, this for example here 1 2 3 1 1 3 0. Okay, it is checking less than. So it will do one by one. So 1 is 1. So 1 is less than 1. 1 is less than 1. No, right? 2 is less than 3. Yes, it is there. It will stop here. It will not go to the next element. So 2 is less than 3, true. Then it will, this whole thing become true. This is how the tuple operation works. Okay. For example, more than, so 2 is more than 1. Yes, true. It will stop here. So this whole thing become true, and it will not do any comparison for the remaining element. Okay. For example, I'm doing the double equal. Okay, because tuple is an inbuilt function, right? Tuple is an inbuilt object. So that is why it is applying, it allows all the operation. Okay. So my custom object is internally leveraging that tuple operation. That's what I'm trying to say. Okay. You got this whole point?
Yeah, understood. Clear.
Okay. So if whenever you have an object and you have multiple property and you want to perform some arithmetic operation, like you want to allow plus, minus, those things on the multiple property, use tuple approach. Okay. I have seen a lot of cases. This is very handy. Okay. Yeah. So total ordering I'm giving here. Yeah. So try this. Okay. Okay. And there is some container function. Okay. Let's suppose you want to create your own custom list. Okay. By default, the list object which you're using right now, we create a list, right? So list up, why we're able to perform some operation like list, we're doing indexing, like list, I want to pull the first element, second element, right? I want to apply membership operator, for example, any element in the list, right? For example, right? Like suppose I want to do iteration operation on the list, right? So like that, suppose you want to create your own custom list. Okay. And you want to allow that my custom object, custom list can allow the membership operator, or it can allow indexing, those things. Okay. In that case, if you want to allow that, then you have to override some couple of functions. For example, length function. Suppose you want to allow the length function to be applied on your custom object. Why we able to apply length on all the sequences? For example, list, I can apply length function. I can apply string, a length function. I can apply tuple, length function. I can apply even dictionary length function. Why? Because this all inbuilt function, they have given the length implementation. Okay, so that's what I'm trying to customize. Suppose I'm creating my own custom things and I want to give the same feature like length, those things, then I can override this function and I can give a feature. This can be a bit advanced. Okay, basically you are creating some customization on your custom object. Okay, for example, suppose I want to allow that indexing. Suppose I have some my custom list, custom object where I can allow anybody can pull some data. Okay, so you can give a get items. Okay, so it will, for example, it will behave like this indexing concepts. Set items you want to, for example, you can see that in the my list, I have a maybe in the backend I have a list. Okay, self. I mean, this list is containing one list internally. Okay. But for the user, you are hiding this, that internally you operating with the list, but for the external user who's using this function, this class, they will consider that this is the object, my list. Okay, but internally using just to maintain the container, just to store something. Okay, you can use a list, you can use a dictionary, you can use tuple. This is your choice. Okay, but if anybody using this and they want to apply indexing or length, those whole things, then you have to provide the implementation. That's what I'm trying to say. Okay, so these are some magic function that this is a very advanced thing. I'm not saying this is always used, this is always mandatory. These are optional things. But if you want to allow user that my object should behave like a list, like a sequence, then you have to override these logics. Okay, so length, how the length will come, that depends upon your internal structure, internal data structure. I have a list here. So here I'm leveraging the length. Length is a global function. So I'm leveraging the length function to get the length of my internal structure. Okay, so that's what you have to define, that what can be my internal data structure. It can be list, it can be tuple, it can be dictionary. On that basis, you can define your functions. You get this point? I hope you're getting this. So get items, set items, delete items, contains. Okay, so contains is for in operator. If you want to allow that my object can be work with the in operator, membership operator, then you have to write contains function. You have to override it. ITR, you want to give iterator. You want to allow that user, my list can be used with a for loop. Okay, then you have to give iterator logic. Okay, this thing. Append, you want to allow to append. For example, see that for example, my class, my list. Okay, here I'm getting a my list and it is behaving like a list. It is behaving like an inbuilt list. Okay, for example, I'm trying append. This is a custom class. It is not an inbuilt list class. Okay, list object. It is my custom object, and on the custom object I'm working like an inbuilt object, inbuilt list. Okay, so here I'm trying to mimic whatever the inbuilt list can do. Same thing I'm trying to mimic here. You getting my point?
Yes, sir. Yeah.
Yeah. So I'm creating my list. I'm just calling append, just calling length, just calling indexing, just calling index. I'm just setting something. Okay. I'm just using in operator. Okay. It is calling contains. Here I'm calling for loop on my list, on my object. It is calling iterator, right? I'm deleting something. So you can see I'm trying to mimic a complete list kind of operation on my custom object. So that's why if you want to do that, if you want to allow that, then you can use container methods. It's very useful. These are the magic methods that you have to override. Okay. Then callable, suppose you want to allow that my function, my object can be called. Okay, then there's a call function. Okay, make the instance variable like a function. Okay, so anybody can call like a function. It behave like a your object will behave like a function. Anybody can call it. Okay, so like this. For example, for example, I'm creating a multiplier. Okay, and I'm giving this is my instance variable factor. Okay, I got initialized. This is my object. Okay, and on this object, I want to call as a function. Okay, so you can see that I'm calling as a function. Okay, I'm passing the parameter. Okay, So if you want to call your function as a, you want to allow that your object can be called as a function with some parameter, then you have to give a call. Okay, then you can override it. Okay.
This is completely strange.
Yeah, this is, I mean, you are giving complete, I mean, Python is giving you complete freedom how you want to customize your object.
Okay.
Okay. You want to create your own list, you want to call it, it's maybe it can be strange for Java thing, but it is giving me more freedom to work with objects. Okay. Yeah, attribute access, I think we cover also. We have a set, we have underscore set attributes, get attributes, delete attributes, get attributes. Okay. You want to allow that custom object, you want to set a property. I think those things you can do that. Okay.
This one we already saw an example, no?
Already we have seen that in previous class also. Yeah, hashing inequality. Okay, how you in Java, right? We want to ensure that my objects are unique or not duplicates, like uniqueness, right? How to manage the uniqueness of different objects. So the same way here also you can implement hash function or equals function. Same thing, same Java concept here. So for that, it has a double equal this function and hash function. You can write your logic how to maintain the uniqueness of two different objects. For suppose I'm creating 2 points. Okay, so how I will make sure that 2 points are same or how 2 points are different. Okay, that you can determine, you can decide. So it's more like a equals in hash code function. Okay. Yeah, and more important thing, this is very important thing, data class. You have, this is very frequently we use this data class things, okay, which I'm going to cover right now, which is very important. Okay, so yeah, so we have seen that in previous classes that once we create any object, right, we have to create init function, right? We have to create equals, we have to give like string representation, like equals, like representation, right? If you don't want to do that, okay, you don't want to write the boilerplate code, okay, you don't want to give this logic. So already this annotation does everything for you. Okay, I mean, explicitly you don't have to write init, you don't have to write constructor, you don't have to write a string function. Okay, so this decorator is added in Python 3.7. It's basically it removed the boilerplate.
Okay. Can we consider this like a Lombok library?
Yeah, it's kind of Lombok. Yes, you can say that. Yes.
Okay.
It is giving you getters, setters, everything. Yes.
Okay.
It is giving you constructor, string representation, equality presentation, everything. Okay. So yeah, so how to use that? So you have to import data classes. Okay. For example, normally we like this. Like we create a class, we create a constructor. Okay. We create a constructor, we initialize all the variable, then we create a representation equals. Okay. So this all thing you don't have to do it. Okay. With the data class, the logic is, I mean, just import, just from the data classes, import data class and just write the annotation, okay? And just define the instance variable. Okay, just create a class and define the instance variable, that's all, okay? So automatically it will create a constructor for you, all the instance variable for you, and equals method and string method, okay? So how it works, let us see some examples. So I'm using data class, classing a user and creating the, it looks like more like a kind of Java kind of code. Okay, so I'm creating a this variable and here I'm giving a type here. Okay, so here in this case you can give a hint. Actually, it's a hint basically. Okay, this type can be anything. Okay, this is not a statically type, but you're giving a hint to data class. It is called hinting. Okay, so it's always a good practice to give a hint. You can declare the type. Okay, you can declare the return type of function. It's a kind of hinting. You're giving a hint. So name is a kind of string, okay? Age is kind of int, email is kind of a string, it's kind of hinting only, okay? And then this is my user, okay? This is very simple, okay? There's no constructor, nothing, okay? And then I can call constructor. Basically, I'm calling constructor here, right? You can see that I'm passing the instance variable name is email, and okay, I'm just getting the instance, getting the object, okay? So it's become very neat and clean code, like you can consider like a Lombok kind of code where you don't have to write those setters, getter, init, those things. Okay. And one more thing, this all, once you're creating the variable like name is email, okay, so you're giving a hint to data class to create a constructor init with 3 instance variable. Okay, so it will consider that this, they will while creating the init function, they will consider this 3 instance variable. Okay, if you're passing this 3 instance variable to create object, then it's okay. But if you're not passing all the instance variable, for example, here you can see that I'm passing only name and age, I'm not passing email here, then it will not work. Okay, so it will give error. So it is, and it is asking that init is missing one parameter. So it is creating init. For what it does, it is creating init internally, and init is accepting 3 parameter: name, age, and email, and you have to pass all 3. Okay, you getting this point? If you don't pass, then it will stop you.
Yes.
Okay, if you don't, suppose if you don't want to pass it, then you can make a default. Okay, let me here show you example. For example, here. Okay, for example, here data class employee. So name is a required thing. Okay, it's a required. You have to, I mean, the constructor will require it. Salary is required, and department string. Here I'm giving a default value. Okay, if you don't give a default value, then it is a mandatory to pass while creating a constructor. Okay, so, and also it has some hookup function. For example, post init. I mean, once installation is happened, once init, once you call the constructor, then do you want to do something, some hookup, some life cycle hookup kind of thing. So there's a post init thing. Okay, so it will call after init automatically. Okay, so this thing, just go through this file, it's very easy. Okay, I've given some example here. Okay, and okay, there are some data class options here. You can create some option. Okay, so while creating this data class annotation, you can pass some option, which is very useful. For example, frozen. If you say frozen is equal to true, it become kind of immutable object. It got frozen. Okay, I mean, you cannot change the once your object got created, it cannot modify the content or in an instance variable. So this way you can achieve immutability here. So frozen becomes true, order become true. I mean, you can, if you're saying true, I mean, you can allow the comparison. It will generate comparison methods for you, like less than, greater than, whatever C, right? Containers. It will create inbuilt for you. Slots too, I haven't used much slots too for memory efficient, but most of the time we have used frozen order these things. Okay, and yeah. And also you can, there's a field option. Okay, while you're defining the instance variable, for example, okay, you can create a field, and in the field level you can pass the what can be the default value. Okay, and you can pretty much customize it. Each field you can customize it. Okay, for example, I'm saying field representation is equal to false. Okay, it means that this I mean, this property will not be the part of representation. I mean, once you're calling print function, okay, this will not display Y. So that much you can do customization. Okay, so representation is false, comparison is a false. Okay, false. I mean, this Z attribute cannot be compared, or you cannot apply less than, double, equal, those things. Okay, so there are a lot of comparison here. Okay, on the field level. Okay, so this data class is important. This is pretty much, we use a lot of time. Data class, so you have to go through, is very important part. Okay, so here are 2 things: is that data part, data class, their option, and their field. Okay, how to customize multiple field. Okay, you don't have to remember right now, but you have to know that these are the things available. Okay, there's a data class, and the data class, there's an option there, there's a field there. In the field we can customize the property. These things you should be aware. Okay, this thing I have given an example. Okay, and one thing in the data class, if you're creating anything data class, okay, all the variable are instance variable by default. Okay, it's by default, it's an instance variable. If you want to create a class variable at a class level, okay, so for that you have to use class var. This thing you have to keep in mind. By default, whatever you create at the class, this kind of thing, okay, at the class level, using the data class, everything is instance variable, because this all thing is getting used by the constructor.
Okay.
Because you are giving a hint to constructor that use it. So by default, it becomes instance variable. Okay, if something that you want to create class level, I mean, the constructor will not consider that, then we have to use class var. Okay, this thing you have to remember. So like this, okay, text right colon, you have to import it class where, okay, like this, okay. So this will not the part of instance variable. It become like a class level, like this. This total is a instance variable, okay. Yeah, like this. So this thing you have to remember, okay. Whenever you want to create instance variable, the by default it's instance variable, or if you want to create a class level, then you have to import class where in the data class, okay. Yeah, so this much is the data class. Okay, this is very important. We use in a lot of cases. Okay, just go through it. Okay, and also you maybe try on internet also. Do some practice also. Okay, so data class we use a lot of time. It's very handy. It's very useful. We use frequent times. Okay. Yeah, there are a couple of things here. One more thing is a name name tuple. Okay, if you want to create any immutable data class, suppose you want to create an immutable data. Okay, you have a class, you want to make it immutable. So it's very simple. Just extend name tuple. Okay, it's very simple, straightforward. You don't have to do any logic. So name tuple do all the logic to make your class immutable. It's inbuilt first. Okay, so if somebody asks you how to make class immutable, it's very simple. Use a name tuple. Okay, and all your property become frozen. Either you can do with the data class also, make the option as a frozen like this. This also become it also make immutable. All the instance will become frozen. Okay, otherwise you can use name tuple. This is also option, name tuple, extend name tuple, and all
but
your
this will generate different constructor for initiation one state.
Sorry.
No, this property will create a constructor for one time, right?
Yes, one time. Yes.
Okay.
So if you try to change something, it will. It will not allow to change. Okay. So yeah, these things I have to cover. Okay. Yeah. Name tuple data class. So data class is very, very important. Go through a data class. Maybe in the program you have to use multiple times data class to make it simple. Okay.
Yeah. Is there any separate library? Documentation for data class?
Data class you can find on the Python documentation itself. Python data class. There's a documentation for it.
Okay.
Yeah, this is a documentation you can find out.
Oh, it's coming as part of language support itself, right?
Yes. Yes.
Okay.
It is not the. It is not the part of Python itself. It's a kind of library.
Okay. Understood.
Okay, so you can go through it. They have given all the documentation how to use it. Okay, so maybe I'm not covering everything, but the basic thing which is required, the high level I've covered. But if you want to go in very depth, you can understand how to do class int. This all thing. A lot of things.
Okay, we get the context. So
yes, frozen instance, inheritance. Yeah, you can do inheritance. Two data class can try to inherit the way the concept was same. Okay. Yeah, but there are a couple of more things that you can go through the things. But yeah, this is important. Data class is important.